Okay, good morning, everyone. All right, yeah, if everyone could just get settled in here, we'll be kicking things off with our formal opening remarks here in just a few minutes. My name is Mark Sheely. I'm the program specialist at the New Mexico Water Resources Research Institute. And I want to welcome all of you here today as well. And I want to get some housekeeping out of the way at the outset here. If you have any used glasses or china, you can deposit them over there once you're finished. And before we get going here, I just wanted to make sure that our Zoom attendees had a chance to wave to everyone and welcome everyone here. So if you'd like to, I see a lot of people have their cameras turned off, but if anyone would like to turn on their camera, just wave to everyone here so we have a chance to see everyone who's joining our meeting virtually today. Yes, thank you, everyone. I'm glad that we could have both virtual and in-person attendees for this, the first kind of hybrid event for the San Juan Animas and San Juan Watersheds Conference. So thank you, everyone. I'm going to go back to share our screen. All right, and with that, I will turn things over to our first speaker who will be giving opening remarks, Paul Montoya. He is a water resource specialist for the city of Farmington. And at this point, he's one of the few conference planning members who's been around since the inception of this conference back in 2016. So it's an honor to have Paul here to open up this year's conference.
Good morning, everyone. Welcome to Farmington. I'm glad to greet you on behalf of the city of Farmington on this, the sixth forum that we've had. I want to call the seventh, but I keep forgetting about COVID and that kind of stuff as well. And you'll notice that I am ancient because I kind of creak when I walk. That's how long I've been around to these conferences. With that, I think I'll introduce our first speaker. Michelle Truby-Tillon is a lifelong resident of San Juan County, growing up on a farm around Bloomfield and graduating from Bloomfield High School. Michelle worked for the New Mexico Department of Health as a health promotion specialist for the San Juan County before moving to the position of floodplain manager under the San Juan County Emergency Management. She serves as the public information officer during the Gold King mine spill, so she's been around as long as I have, and was involved in numerous public emergency during the 16 years with emergency management. Michelle was promoted to the community development director and continues to serve as a floodplain manager for San Juan County. So with that, would you please welcome Michelle? Good job.
You did good, thank you.
Thank you, welcome.
Well, it's nice to see everybody here and on the screen waving. That was nice. You know, San Juan County is made up of 3 rivers. We're very dependent on our rivers. We're very lucky that we have, and blessed that we have one of the last free-flowing rivers in the United States, in the Animas River. Even when we're experiencing drought conditions in our area, as long as it snows in the mountains, we're good. We have water for farming, we have water for drinking. Unfortunately, it creates a dependency that's kind of false in its security. Public perception has always been that we're always going to have water. It's coming from the mountains. We're never going to be dry, even though we're a drought area and we've been in severe drought for quite some time. More than once, we've seen the Animas River run dry lately. That's scary. That puts it in people's minds that maybe this water isn't always going to be here. You know, if you can walk across the river and not get your feet wet, it's scary. If you're a farmer and you're at the end of that ditch that doesn't run past June, you have no crops past June. It's not good. One of the biggest things that occurred, at least in my lifetime, on that river has been the Gold King mine spill. It was a worldwide sensation. The Animas River for a small period of time became a star. Not necessarily in a positive way, but it did show our area and the beauty that's here and the fragility or the fragileness of the river itself and the things around it. It showed farmers that maybe we've got some issues, and the water providers. How much did they lose? How much did they not catch whenever they were having to shut in and their storage units weren't big enough to maintain their clientele? We learned a lot really fast about what we didn't have. But what we did have was we had planning and preparation through emergency management in this area and partnerships. So those partnerships kicked in right away when we started having problems. Everybody came together as a community, and we learned from our mistakes in the past that we had made in other disasters to create a stronger response to this particular disaster, even though we'd never had this before. One of the biggest things that came out of it was the domestic water users and their ability to partner with other agencies as well as providers in the community for drinking water. Because some of those systems, they were down to zero and they were going to have to start hauling water into areas. One of the other things that came out of it were the partnerships with industry. Even though we didn't know what was coming our way, we knew it was coming. We could see it. It was orange. We didn't know what was in it right away. Industry deals with spills all the time in rivers and the ocean. The technology was out there, and they immediately jumped up and said, hey, we've got this, we've got that. Let's look at that. Let's look at this, and started working their way towards a solution. Some of it wasn't implemented, but it definitely was available. Then we had to deal with cross borders, federal as well as state borders. This river has such an impact on so many people, and it was really brought into the forefront with this spill, how much this river means to how many people. It's not just Silverton to Farmington. It goes all the way down to Lake Powell. It hits right into the San Juan and headed right on down, went through Utah, went through Arizona. We've got problems all over the place that came from this. One of the big things that my office took away from it was the amazing amount of people that showed up from the federal level to the local level in our emergency operations center. We had people from all kinds of different agencies that I didn't even know existed, uniforms I'd never seen before, including medical uniforms, just to deal with water treatment and stuff like that, people being maybe getting toxins from the water they were drinking. We continue to have water testing just to make sure that nothing is still seeping into somebody's well or that's still running loose every time we get a spring runoff, bringing stuff down. But we did get to see the full picture of the impact of our river. We also got to view some of the work you people have done, different agencies that are in this room, the history that you guys have created, the data collection points that you were already working on that were brought into play for baseline measurements, especially when it came to some of the heavy metals that we were expecting to come in to play. And I can say honestly that that work was appreciated. And the continued work that you do, the passion you have for this river and the rivers in this basin, and the quality of water as well as the quantity. Quality of water is very important. I know we have problems with our quality, but again, people like you working towards a solution and keeping an eye on things for the rest of us is applaudable. It's a very important process, and we do appreciate it. I want to thank you guys again for all the hard work you're putting forward and all that you've done in the past, present, and the future that you will do, this conference being part of that. But hopefully you'll get out, if you're not from here, enjoy some of our beauty out there, get to some of our local flavor food special spots. If you don't know any of them, I bet you there's somebody in the room who can tell you. And I hope you enjoy your stay here. Please, thank you. Thank you for having us, and welcome.
Okay, thank you so much, Michelle. And with that, we're going to be beginning the start of our formal oral presentations. And let's see, just a few notes here about the program today. We've had one change. So our presenter, Warren Ryder, at 2 o'clock, he announced that he wasn't going to be able, or he announced earlier that he wasn't going to be able to make the conference this year or today due to health reasons. So we won't be having his presentation, but we're going to see about possibly moving the rest of the afternoon schedule up. So we'll possibly start our poster session a little bit early, about a half an hour. A note for our presenters, if you have slides, we do have a little slide clicker up here that you can use to advance through. So that's available to you. And we are aware of certain presentations that have notes in them, so we can enable the presenter view for you for those. But if there's anyone else who would also like to have that presenter view, just let me know. For our virtual attendees, what would work best is to have any questions for the Q&A portion submitted in the chat, and we'll have those ready to relay to our speakers. And then for those of you in the audience, feel free to come up to the microphone up here with your own questions after the presentation. So with that, let's welcome our first presenter here, Peter Butler. Peter Butler has worked in the abandoned mine and water quality issues in the Animas River Basin for almost 30 years. He worked with the Animas River Stakeholders Group for 25 years and served many years as the group's coordinator. He's currently the chair of the Bonita Peak Community Advisory Board, advising the EPA on issues regarding the Bonita Peak Mining District Superfund site. Peter has a bachelor's degree in physics, a master's degree in economics, and a PhD in natural resources policy. Peter, if you can, come on up.
Thank you and good morning. Good to see all of you this morning. Let's see if I need to move this around a little. Does that work well for volume? Okay, great. Thank you. So I'm going to give you a little bit of an update about what's been going on since the Superfund designation in 2016. To start off with, the designation occurred in September, about a year after the Gold King mine spill release. The Superfund mining, or the Bonita Peak Mining District, is actually a made-up name. There is no such thing as Bonita Peak Mining District. The Bonita Peak is the peak that the Gold King mine actually is in. The reason for that kind of funny name is that the local people up there around Silverton, San Juan County, didn't really want to be labeled a Superfund site, and so they didn't want the town of Silverton or the name of San Juan County involved in that designation, and so that's why this mining district was made. Essentially, this is the area up around Gladstone, which is up around headwaters of Cement Creek. The Superfund designation consists of 46 mine sites and 2 study areas. There are no set boundaries to this district, to the Superfund site. If they found sources of metals that were causing contamination issues down here in Farmington, the Superfund district could actually be extended all the way down here to Farmington. Now, I think that's highly unlikely. I don't foresee that they're really probably going to add any more mine sites or any other areas to the Superfund site at this point. And in fact, I think some of these 46 mine sites probably didn't necessarily belong on that initial list. Some of them are pretty small and pretty minor. There's also no boundaries around those mine sites either. So it's not clear if you have claims up there, whether you're in or out of that particular or out of the Superfund site. Excuse me. There are 3 site goals that EPA designated for the Superfund site. One is to improve water quality. The second is to stabilize source areas. And the third is to minimize unplanned releases like the Gold King mine release. Stabilizing source areas means essentially kind of maintenance issues around mine sites, keeping the discharge coming out of the mine from going over mine waste, pulling mine waste out of the river, if it's right along the channel banks, mucking out sedimentation ponds, things of those nature. This is a map of the excuse me, of the area around the Superfund site. All those little yellow dots are those 46 mine sites that I had noted earlier. If you look at this map, the town of Silverton's kind of right there in the middle of that map. And then over to the left where it says number 4, that is that's a section of Mineral Creek. And that's the section, that's where the highway goes up over Red Mountain Pass. And then, of course, going down below Silverton, down at the bottom of the screen, that's the Animas River leaving Silverton. These 4 areas are target areas for EPA for water quality improvement and for improvement of fisheries and habitat. A lot of these other areas up in this up in the district, they either have very poor water quality and we don't ever anticipate seeing aquatic life or fish in those areas, or some of these areas have very good water quality that doesn't need to be messed with at all. Overall, there's been a lot of money has been expended up at this Superfund site. Before the Superfund site, EPA spent approximately $30 million in response to the Gold King spill. Since the Superfund designation, we estimate that they've spent on the order of $70 to $75 million since 2016. We don't know exactly how much they've spent because EPA won't tell you, because that's part that could potentially be a source of litigation, which I'll explain a little bit more about later. In addition, Sunnyside Gold Mine Corp, which is the kind of the large mining company that was associated with the work up there, has spent about $15 million since 2016 doing most of the investigations on the Mayflower tailings. Sunnyside spent approximately $30 million before that doing a lot of mine remediation and reclamation over 25 years before the Superfund designation. There's also been smaller amounts spent by BLM, Forest Service, Colorado Department of Public Health, and there's also some other small private property owners that have done some work on their sites under a cooperative agreement with EPA. Also note that picture. That is what happens when you get a very heavy rainstorm in Cement Creek. So this was not the Gold King spill, but this is after a storm in 2020. What has gone on since all that money has been being spent up there in the past 5 or 6 years? Well, I'm going to start with the activity in the Gladstone area. This is the area that's the big source area for most of the metals in the Animas Basin. There's been treatment of the Gold King mine discharge. That actually began about 3 months after the Gold King spill. They actually set up EPA got a treatment plant put in there amazingly fast and got it going before the winter storms started to hit and the snow really started to pile up. And that treatment has been ongoing since that time. There's also the Red and Bonita mine, which is down the hill from the Gold King and is probably just about as big a source of metals as the Gold King mine. Bulkhead had been installed in there in 2015, almost exactly the same time as the Gold King mine spill. But it was not tested. Nobody did anything with it after that bulkhead was put in until 2020. It has a pipe in it and it has a valve. So the valve was open and so the bulkhead wasn't preventing any water from coming out. That was tested in 2020 for about 4 months. And then the water was drawn down. They were testing it to see if there was any leaks, and if there was seepage in other areas. And they opened that valve slowly and removed the water and ran it through the treatment plant But now it is currently open and that water is not being run through the treatment plant. The red bonito has only been treated during this test. Otherwise, it is not treated at this facility that you see the picture of. It's also been a diagonal well has been drilled into the American Tunnel behind the first bulkhead. The American Tunnel is the access point to the Sunnyside mine, which is by far the largest mine up there in the district. They've drilled a horizontal borehole along next to the mine portal in the Gold King. EPA has done that to test the rock. They are considering whether or not to drill a new tunnel back into the Gold King workings. They're concerned that the current tunnel is unstable and they may want to put some kind of bulkhead back in the Gold King. That has not yet really been decided whether they're going to try to put that new tunnel, that new portal in or not. But they've drilled a borehole for it. They're also planning to drill wells down into the Sunnyside mine pool from kind of across the ridge from the Bonita Peak into what used to be Lake Emma. I was actually up there with EPA yesterday looking around at potential drill sites in what used to be a lake bed up there. And then there's been an enormous amount of sampling going on throughout this area around Gladstone. In other areas, again, an enormous amount of data collection happening all over the basin. There's been some investigative well drilling behind some porthole collapses where you have the portal is on a steep hillside. You have a bunch of debris that might come down over the porthole and block up water. And EPA has been checking to see how much water is behind there, trying to drill behind the Terry Tunnel collapse and the Bandora. Actually, the Terry Tunnel was not collapsed; it was backed in, and the Bandora collapse. They've been investigating fluvial tailings upstream of the Howardsville mill. They removed a bunch of hazardous chemicals from the hazardous mill. It was discovered that there were many barrels and other containers full of hazardous material, such as cyanide. And EPA went in there with their hazmat team and removed all that material and took it to a safe disposal site. They've also done some source stabilization at about half a dozen mine sites. This involves things like this picture that I show you here, where they have captured the drainage and made sure that it's secure and not going over the mine waste pile. They've also been working on the design of a permanent repository at the Mayflower Tailings Repository number 4. They're hoping to start construction of that next summer. But I think what's kind of important to note is that there have been no really large significant water quality improvements up there other than the treatment of the Gold King mine, which had been going on since before the Superfund site. Here's a couple photos of the Mayflower repository. That's kind of a big deal that they have a repository to take some contaminated materials. The one on the right there is an aerial photo of the tailings pond, or there was a tailings pond. It was reclaimed in the 1990s and remediated by Sunnyside Gold. And there's a large flat surface area there, about 35 acres, and that's where they want to put a repository. It'll be a line repository. It's a large flat space. There's not many large flat spaces available in San Juan County. It's just a very difficult thing to find. So I'm sure many of you are thinking, that's a lot of money that they have spent. And there has not been a whole lot of work on actually improving water quality. And I think a lot of that has to do with the Superfund process. The Superfund process is designed to support litigation for cost recovery. So what that means is that EPA can clean up sites, and then they can pursue what's called potential responsible parties, or PRPs, to recover the costs that they spent in cleaning up that site. And PRPs include current or past owners or operators of any of these sites. And of course, obviously, some of these sites have records going back 100 years. There's potentially a lot of past owners and operators, although many of them are long gone and many of them are bankrupt. However, deep-pocketed PRPs can be held responsible for all the costs of the site, even if they only cost a small portion of the damages. This is why, in particular, a lot of large corporations are very opposed to or really don't like Superfund processes, because they can be held responsible for a lot of things that they may not necessarily have created. The other part of this is that EPA may go after a PRP for the cost of the site, and then that PRP may turn around and sue other PRPs to recover their costs from that site, or recover costs that they don't think that they should be charged by the EPA about. So that leads to an enormous amount of potential litigation. The other thing that is important to note is that EPA doesn't use previously collected data. There's been a lot of work up there in the Silverton area before the Superfund site. There were approximately 60 mine remediation projects that were completed starting in the early 1990s up until the time of the Superfund designation, or up until the Gold King spill. They look at that data, but they can't use it because everything they have to do has to be litigation proof, and they can't defend other people's data. And that's a big reason why they've expended an enormous amount of costs. Everything has to be appropriate for a legal setting. So they have to develop very detailed, long detailed plans for sample plans, for any type of information that they are collecting. They are supposed to follow the evidence, almost like an investigator in a criminal lawsuit. They are supposed to follow the evidence and go where the evidence leads them into figuring out what the solution might be at this particular site. And it costs a lot of money to do that. So in terms of cost recovery, the largest PRP or private PRP is Sunnyside Gold Corporation. And they have now reached a settlement with the United States government. The settlement was approved by the court about 2 months ago. There will be a payment of $90 million in total as part of that settlement. And that's divided equally between the US government and Sunnyside Gold, indicating that there's equal potential liability for government agencies and the mining corporation. BLM, Forest Service, and EPA are all PRPs at this particular site. BLM and EPA and Forest Service are PRPs because they own some of these mine sites within the basin. And for example, the entrance to the American Tunnel, where all the mining was done at Sunnyside Gold, is actually on BLM land. The Mayflower Tailings Pond number 4 that I showed you earlier a picture of, that was on BLM land as well. And it was transferred, I think, about 15 years ago to Sunnyside, but that was well after the pond had been built. EPA is a PRP because of their role in the Gold King spill. And to my knowledge, EPA has never been a PRP at a Superfund site. So what happened in the settlement is that actually the US government is paying for half that settlement and Sunnyside Gold is paying for the other half. What that settlement means is that the US government will not go after Sunnyside Gold for any more responsibility for the site. Sunnyside Gold will not sue any of these federal agencies, and federal agencies will not sue each other. And Sunnyside Gold will also not sue any other private PRPs. So this lifts an awful lot of the potential litigation that could go on for decades and cost hundreds of millions of dollars. We feel that this is actually a turning point within this district. It does provide a certain amount of settlement money, which can be used to clean up the areas up around Silverton. But it also kind of drops the potential for most of the litigation. There still could be some litigation between some of these small parties owning some of these small sites, but most of them are pretty small potatoes. So we also hope that there will now be a lot more free-flowing information between all these different federal agencies, the public, and the different companies, because everyone's held their cards very close to their vest and not wanted to share very much information at all with anyone because of the potential for litigation. So a little bit of activity, I want to talk a little bit about some of the activities of the Bonita Peak Community Advisory Group, which is the one I'm the chair of. It's also known as a CAG. It is an officially recognized group of diverse stakeholders under Superfund law. And we act as liaisons between EPA and the local community. And all members have to be in the Animas watershed. There are 15 members, 4 are appointed by local governments, City of Durango, City of or Town of Silverton, San Juan County, Colorado, and then La Plata County in Colorado. And the rest of them are at large. We have monthly meetings to discuss, and they often get into fairly technical aspects of what's going on in the district. We often provide governments detailed comments on EPA documents. We maintain a website. If you Google Bonita Peak CAG, you'll find it. Excuse me. And we sample monthly between Silverton and Baker's Bridge. This is the Animas Canyon. This is the area where the train goes up. There's no roads. It's very difficult to get in there. The agencies felt it was too costly for them to sample in there themselves. So we hike in about 11 miles a round trip and sample at a couple locations. In the wintertime, we ride the train into Cascade to sample. And then our other sample point near Silverton, we ski about 13 miles round trip down the tracks to get samples in the middle of winter. And this has provided very valuable data. We also have proposed water quality standards for one particular segment. This is segment 4 on that map. There have been over a dozen mine remediation projects before the Superfund designation up around Red Mountain Pass. And those projects were completed by the Animas River Stakeholders Group, mining companies, and the Forest Service. And we've seen great gains there in terms of water quality. Zinc cadmium concentrations dropped by 72%. Copper concentrations dropped by 95% in the creek there. And much to everyone's surprise, brook trout moved into that particular site. And we now have brook trout there where there was no aquatic life previously. Excuse me. There is no aquatic life use classification or accompanying standards on this segment. And so the CAG has proposed adding those to protect the water quality that there is today. That proposal goes before the State Water Quality Control Commission on Monday. We've been going all through that process. And part of our rationale for doing this is that we feel like it's time that we start determining goals for the Superfund site. Where are we going? What's feasible? What's not feasible? And we need to initiate that process to determine what the goals are and then move towards those goals, instead of just spending a lot of money doing a lot of studies and not having an end point to where we might get to. So that was part of our rationale for proposing this. And I think in the future, we may look to propose water quality standards in other segments as well. And since I seem to be losing my voice a little bit, I think I better stop there and see if there's any questions.
Everyone, feel free to come up to the microphone here to ask any of your questions. And also for our Zoom attendees, I just put a little message in the chat, but feel free to put your questions in there as well, and we'll relay them to Peter.
I don't know too much about this stuff, but why were they drilling these holes down into the mines or whatever? What was that about?
Sure. This is up at Lake, there are a couple of different places. The reason for drilling them behind the collapses that are kind of at the surface is you want to see what the water pressure is behind that. The concern is, will that cause another release? And so you want to see what the water pressure is in the Terry Tunnel. Sunnyside Gold covered the front. There are bulkheads farther back. EPA wanted access to those bulkheads to see how they were holding up. So they drilled behind the collapse before opening it up because they didn't want to release a bunch of water. They pumped the water out from behind the collapse. Then they removed the collapse in the front. And actually, I shouldn't call it a collapse. It was actually buried by Sunnyside. And then they went back in to investigate the bulkhead and see what the integrity was. With a Bandora mine, it has been collapsed. It's been collapsed a long time. We're pretty clear that there's a lot of water backed up there, and people want to see what the pressure is and if anything can be done about it, or if it's imminent, if there's an imminent release or not. There's dozens of mines up there that have collapses in the front and have water backed up in the workings, and it's a real tough problem to figure out what to do about them, or do you do anything about them? That question.
Yeah, you mentioned there's a water treatment plant that hasn't been treating very much water except when it was going through some testing. Do you know why that is and when it's going to be running full time?
The water treatment plant is actually a plant for treating the Gold King mine. And so that has been continuously operating. The issue is there are other mines very close by that could also be treated, particularly the Red and Bonita and the water that's coming. There's some residual water coming out of the American Tunnel, which has bulkheads in it. That was not part of the initial response reaction. The CAG has actually continually pushed EPA to treat some of these other mines. EPA's position is that they would have to go through a lot of process. That's not part of the final solution, and it would cost a lot of money. I think there's some liability issues regarding it too. The water coming out of the American Tunnel is on BLM land, and BLM doesn't want to pay for any of these treatment costs. That treatment of all those mines could be a future solution, but at this point, they're not being treated. And again, that's something that we have pushed for and has not happened.
And then a follow-up to that, do you know if maybe to offset some of those treatment costs, if there's possibility to recover rare earth metals to pay for some of the treatment? Do you know if that's being considered?
It's certainly that has been discussed many times over the years. There used to be there's been a treatment plant there previously that Sunnyside Gold ran, and then it was shut down in 2002. And then a new treatment plant was put in that same location in 2015. It is very difficult to remove those metals, particularly with the type of treatment process. That's certainly something people have been interested in for a long, long time. But nobody's been able to technically make it. Well, technically you could make it work, financially make it work. Yeah.
In terms of ecological restoration, at what point can you define that the anthropogenic causes of the mine waste is taken care of and the natural baselines are continuing to leach into the river system? And how do we know that we have cleaned up after human activity? What are you using to measure that?
That's a good question. I think the bottom line is there isn't a good measurement for figuring out what's anthropogenic and what's not. My response has been that there's at least 150 to 200 draining mines up there in the Animas Basin. There's probably, if you just looked at little mine pits and mine sites, you could probably find close to 1,000 of them up there. We're not going to clean them all up. And most of them don't need any cleaning up. They're not doing much damage at all. What we found, this is with the Animas River Stakeholders Group a number of years ago, we sampled about 150 mines, found that 4 mines accounted for 50% of all the metals compared to the other 150. Those 4 mines are the ones up there in Gladstone, like the Gold King, the Red and Bonita, the American Tunnel, and then the Moguls, the 4th one. I think my position has been you can spend an enormous amount of money and an enormous amount of time fighting over what's anthropogenic and what's not. And my sense is you're better off figuring out what's feasible to clean up and go after that, recognizing that you're not going to get every single drop of water that might be caused by anthropogenic sources. Any other questions?
Yeah, so you had mentioned that you guys wanted to set up some water quality standards for your cleanup. Do you have a plan for how you are going to establish those?
It has a lot to do with feasibility. Again, it's what's feasible in terms of removing these sources or mitigating these sources. The standards actually being proposed for the segment 4 are what's called, the state of Colorado calls the table value standards, which are protective of 95% of all aquatic life. And those are the standards that are applied throughout the state to protect aquatic life. I actually don't think that they're feasible to maintain, to reach those table value standards year round. During spring runoff, metals concentrations tend to be a little higher. But that's something we're gonna have to sort out later. And basically in sorting that out, we've already gotten a lot of the low hanging fruit to get those large metal reductions. There's not a lot more that can be done, but probably a little bit more can be done. And we're gonna have to spend some time figuring out how much difference that'll make in terms of improving the water quality, at least during that spring runoff time period. Otherwise, the standards are essentially protective, the same standards that we would apply throughout the state. Any other questions?
Thank you for the presentation. My question is, how much of the heavy metals is down the river for the people who are farming and ranching so that these heavy metals do get into the food chain? Do we know that? The question one. The second one is, I've heard a presentation by 3 universities, and part of the information you provided wasn't included, such as all the potential litigations that are there.
I'm sorry, as I say the second question again.
The second question is, how the information you provided, the Superfund, the effort, the activities, and the liability of information that's shared or not shared. There were 3 universities that I've heard present, and they didn't share that kind of information other than, yeah, we're trying to do something about it. We want to know more.
Yeah, so if you're, let me actually deal with that second one first. If you are a scientist working for a university, you don't have any kind of liability whatsoever regarding the work that's being done up there. So you're free to share that information unless somebody funding it doesn't want you to, which I don't know why they wouldn't. So there's not I feel totally free of sharing whatever information that I might have, because I have no liability regarding any of these sites or any of these properties. Where there hasn't been a free flow of information is people who have liability. For example, Forest Service and BLM have liability up there. They've been doing sampling. They don't share that sampling. They don't even share it with EPA, or they haven't been. They're starting to now, I think. Because they were afraid that it could be used later in litigation. So that's why I think the settlement is so important, is that I think some of that information sharing may now occur. But the only information that people aren't sharing is the ones that they might are people who have potential liability. With your first question about metals coming down the river, yes, metals do come down the river. Of course, metal toxicity is based on concentration. And as you have more water coming in, you have lower concentrations. But it certainly does come down the river. Is it being taken up in the crops? I think there's been a number of studies that haven't found that, but it doesn't mean it's impossible for it to be taken up in crops. Most of the metals The metals that we see really high concentrations of that affect aquatic life in particular are zinc. And zinc is not particularly toxic to humans, but it is quite toxic to aquatic life. Fortunately, we don't have some metals up there that would be more of a human health hazard. They used very little mercury up there in the mining processes, so we don't see any mercury coming down. We almost never see arsenic above detection levels. Lead, we do see some lead, but it's not above any human health standards at all. The metals that are of most concern for cleaning up in the water quality tend to be zinc, a little bit of cadmium here and there, but the concentrations aren't all that high. For example, in the Animas Canyon right below Silverton, we've taken samples now for monthly samples for 3 years. We have only seen dissolved lead be above detection limits once in about 100 samples, and it was just barely above detection limits. So I think most of the metals that are human health concerns, we don't think are coming from Silverton all the way down here. That doesn't mean that they're not in the water here. There could be other sources too.
Thank you.
Yep. I think I'm running out of time. Was there one other question or not? All right. Well, thank you very much for your time and your indulgence. And again, if you look at if you type in Bonita Peak CAG and find our website, there's an enormous amount of information there and a lot of links to a lot of different studies. And EPA has a very extensive website of information as well.
All right, and while we get the laptop and display set up for our next presenter, I'll introduce him here. Oh, here I can move over. All right. Okay. So Ty Churchwell is on staff for the National Trout Unlimited, America's oldest and largest cold water river conservation organization, headquartered in DC. In his capacity as mining coordinator for Trout Unlimited's public lands program, Ty works primarily on federal mining policy as it relates to healthy trout salmon fisheries and public lands. Ty, come on up, and thank you so much for presenting today.
Very good. Thank you, Mark, for getting that put together for me. Good morning, everyone. I think we got a PowerPoint up here for you. Sorry for the delay there, but it's rather important I have this in front of me so I know what I'm speaking about. My name is Ty Churchwell. As was mentioned, I'm on staff for Trout Unlimited out of our office in Durango. And I'm here today to talk with you about Good Samaritan legislation that will tie in very nicely with what Peter just mentioned about Bonita Peak. So it's pretty obvious to everyone in this room that mining is a part of our heritage here in the West. It established many of the towns that we lived in and encouraged westward expansion, definitely fueled the Industrial Revolution. And it's important to note that the impacts of mining are still felt today. We have an abandoned mine problem in this country, and in particular in the West. All of these photographs on this slide happen to be from the upper Animas, but the issue of abandoned mine drainage and water pollution emanating from them is quite extensive, as can be seen here. The photograph there, all of those black dots are abandoned mines, and EPA estimates that there are about 500,000 abandoned mines in the United States, most of which are in the Western United States. EPA also estimates that about 40% of headwater streams are impacted by acidity and metal loading emanating from abandoned mines, and this impacts about 110,000 miles of rivers. Again, most of that in the West. Those are rivers that have 303D listing on them for acidity and metals from abandoned mines. The estimated cleanup costs are massive, as you can see there, and quite frankly, Superfund is only one of the tools that we can use to clean up abandoned mines. But EPA lacks a lot of manpower, sufficient funding, and in many cases, they lack the authority to address some of these draining mine issues. So when we talk about abandoned mines and mine pollution emanating from them, it's important to note that there are really two different kinds of mining pollution. There is point source, which is there on the left. You can see that there is actually water emanating out of a tunnel, and that is the Kohler Tunnel at the top of Red Mountain Pass. That's an older photo. As Peter mentioned earlier, there is a bulkhead in that mine, and there is significantly less drainage coming out of that one. But that's point source, where water is actually emanating out of the mine portal. The other issue is non-point source pollution. And as you can see there on the right photograph, that is a waste rock pile, and pollution that emanates from non-point source is typically water that infiltrates or runs across one of these waste rock piles and picks up contaminants and then moves it downstream. So it is important to note that there are two different types of pollution, and the Clean Water Act, in fact, differentiates between these two types of pollution. So let's talk real briefly about non-point source. Again, these are waste rock piles. They are often near or sometimes right on top of a creek, and for lack of a better term, the Clean Water Act deals with that sort of mining pollution as if it were soil runoff. Under current laws today, it is allowed for Good Samaritans or non-responsible third parties to perform cleanup projects at these types of mine sites. Simply, the waste rock piles can be moved, water can be rerouted around waste rock piles, or you can put a cap on the waste rock pile to keep water from infiltrating down into the pile and bringing contaminants into surface water. So again, I just want to point out these types of projects can be performed legally today. The Animas River Stakeholders Group here in the Animas Basin performed dozens of them. The state of Colorado performs these projects, and my organization, Trout Unlimited, we also have people on staff who perform these types of non-point source cleanups. There is, however, a legal quagmire, a bit of an issue, and that involves point source water pollution. Under the Clean Water Act, this is considered industrial pollution, and as such, the person or entity or business that creates that industrial pollution is required to get a wastewater discharge permit. They're required to treat that acid mine drainage and treat it to a very, very high water quality standard before that water can be discharged back out into a creek. And the industry must maintain that permit and that water treatment so long as the pollution source exists. So you can imagine a factory that produces some sort of a product. They have a waste stream of water. As long as they're an operating business, they have to clean that water up before it can be discharged into a creek or river to run downstream for other users. That works very well when you have an owner or an operator. But at an abandoned mine, the miners are long gone. The company, the mining company, is long gone. So we have a bit of an issue there. The issue for draining mines in particular is they will likely continue to drain forever and ever. As long as it continues to rain and snow and water infiltrates down into a mountain, it will find its way into the mine workings and discharge water out into the environment. The caveat with that, as I've noted here, are bulkheads. Bulkheads can help control that water and limit it, but the larger point is that the draining mines continue to drain long after the industry has left. So right now there is a disincentive to cleanups by third-party non-responsible people. Those are anyone who didn't create the mine pollution but wants to clean it up. Again, state agencies are examples of entities that might want to be one of these third-party non-responsible parties to take on one of these cleanups. But there are huge, huge disadvantages or disincentives, excuse me, to anyone attempting to clean up one of these sites. Most notably, Good Sams are not well suited to hold discharge permits forever. And that's one of the rubs with the Clean Water Act is once you take on that site and say, we're going to clean it up, you are legally responsible for that pollution in perpetuity. Again, the miners are long gone. So if you step up and say, we're going to take it on, now you're permanently liable forever and ever for a problem you didn't create when all it is is that you're trying to clean up the mess. So in order to meet the very high clean water standards that are required of one of these cleanups, you have to use active treatment, much like is up at Gladstone in Bonita Peak. These types of active treatment systems require electricity and roads and the addition of chemicals and infrastructure and so forth. And so it's quite expensive. Additionally, you have to meet 100% attainment of water quality standards with that cleanup before you can discharge that water back into a creek to run downstream. So under current laws, a partial cleanup or removing only some of the metals is essentially in violation of the Clean Water Act. So under current laws, and again, Peter gave an excellent presentation on what's happening in Bonita Peak upriver here in the Animas Basin. That was a really good segue because I want to talk about the limitations of Superfund. Right now, that is the only legal mechanism by which anyone can address one of these abandoned mine sites. And Superfund is well suited to address major mining operations and pollution sources, especially where human health risks may exist. Again, as Peter noted earlier, the premise behind Superfund is that the polluter pays, that the EPA can go back and seek cleanup costs from a responsible party, and that works well and good when there is a responsible party. But in an abandoned mine, the miners are long gone. The mining company is long gone. So there is no way to recover costs at an abandoned mine site because there is no one to hold responsible. Superfund is pressed to the limit right now. There are over 1,300 Superfund sites in the country right now awaiting attention and action. The ability of the EPA to address Superfund sites is a function of funding. And Superfund is funded through appropriations through Congress, and it is underfunded right now. It is very expensive to operate one of these wastewater treatment plants, and it must go on in perpetuity. And additionally, the state in which the Superfund cleanup is occurring generally takes over maintenance cost after 10 years of completion with that product, with that cleanup. So Superfund works really well in some locations. It is the choice for the upper Animas, but it is not appropriate at other sites. I want to talk to you about the little bleeders. And again, to piggyback on Peter, he had mentioned that the Animas River Stakeholders Group had identified and categorized and characterized over 160 draining mines in the upper Animas basin alone. But many of those are what I like to call the little bleeders. These are sites that are very unlikely to ever qualify as a Superfund site. There are tens and thousands of these around the Western United States. They often have quite small discharges of water, anywhere from say 1 to 50 gallons a minute. And to put that in perspective, the Gold King, depending on which time of year it is and whether it's a wet year, a drier year, discharges hundreds of gallons a minute. So that's a major loading source and a much bigger problem. These little bleeders are often in very remote locations. And again, the upper Animas is a perfect example of that. Many of these sites, you have to four-wheel drive into them. You have to hike into them once you drive up there. There is no road. There is no infrastructure, electricity, et cetera. So these continue to be a really big problem because they would not qualify as a Superfund site. And so with no legal mechanism by which anyone can clean up these sites, and by anyone, I mean even the EPA, it is only under a Superfund listing can they do this. And if these sites don't qualify for a Superfund listing, there is no mechanism by which anyone can clean up one of these abandoned mines. And they're going to bleed year after year, decade after decade, until we figure out some legal mechanism by which those cleanups can occur. Again, I already spoke to this point, but there are over 160 sites in the upper Animas that are draining mines. Only 46 of those qualified as a Superfund site. So that leaves 120 plus that have no legal mechanism by which anyone may clean up those sites. And I'm here to talk to you today about Good Samaritan legislation, which attempts to fix this problem. So it's not really a new tool. We've been talking about Good Samaritan legislation for about 20 years. There have been numerous bills introduced over the last 20 years, none of which have made it to the president for a signature. So I'm not sure I'd call it a new tool. But the legislation I'm here to talk about today is in fact a newer attempt at trying to pass legislation to affect these abandoned mine cleanups by non-responsible third parties. So in February of this year, Senate Bill 3571, the Good Samaritan Remediation of Abandoned Hard Rock Mine Act of 2022 was introduced in Congress. The lead Senate sponsors are New Mexico's very own Senator Martin Heinrich, and joining him in bipartisan co-sponsorship is Jim Risch, a Republican out of Idaho. Right now, with this active bill that is moving its way through Congress, there are 12 additional co-sponsors and several others that have agreed to come on. They just haven't been added just yet. Those 12 co-sponsors are equally split between Republicans and Democrats, and you can see that darn near every Western state has one, if not two, of their senators already on board in co-sponsorship with this legislation. I can tell you with all of the Good Samaritan bills that have been introduced in the past, we have never had this level of co-sponsorship and bipartisan co-sponsorship. And so I think that speaks very highly to the bill that we have developed and its agreeability. Again, others are coming on board. Both of New Mexico's senators are on board, both of Arizona's, both of Colorado's, both of Montana's, Wyoming, Idaho, et cetera. So our hope is to have every Western senator on board in co-sponsorship soon. And we are currently working on House sponsorship as well, because you have to have the other side of Congress on board in the House. So what this legislation does and how it is different from other Good Sam attempts of the past is it creates a pilot program. If this legislation were to pass, and we continue to work very hard daily to get this to the president for a signature, it would approve a 7-year pilot program under EPA jurisdiction. What it would authorize is 15 low-risk projects that can be performed anywhere in the United States. Most likely they will happen in the West, as that's where the problem is most pressing. So again, 15 low-risk sites. And by low risk, what we mean are these are sites that do not have a blocked portal like the Gold King. So there would not be any issue associated with an unplanned release at one of these pilot sites. Again, they're likely to be very small discharges of water, certainly not the scope of water that we have at the Gold King in the hundreds of gallons, but something less than that, like 50 or less. And the constituency of that water is very likely to be quite small in metal loading. So it's not a big environmental hazard as it exists today, but there would certainly be improvements that could be made. These pilot projects can be performed on private, public, or mixed ownership sites and tribal lands as well. Basically, what the program would do would be to create a new discharge permit under the National Pollution Discharge Elimination System program. And it would be a new permit by which a Good Samaritan could apply for one of these permits to perform one of these pilot projects. As I noted earlier, the liability associated with mine discharge is really the major rub with third-party organizations or entities performing one of these cleanups. Again, there's a liability associated with it. In the absence of the actual miners who created the problem, the liability is given to or forced upon, if you will, the third-party entity that wants to clean up one of these sites. So what Good Samaritan legislation does is it gives targeted liability relief so that those entities can perform one of these cleanups without running afoul of the Clean Water Act. Basically, the permit is an if-then type of scenario. A Good Samaritan would identify a site that they want to clean up. They would create a remediation plan, a safety plan, of sufficient bonding and financial obligations, and they would present one of these ideas, if you will, to the EPA. If the EPA were to approve one of these pilot projects, as long as the Good Samaritan meets the conditions of their permit, they are given liability relief. In other words, they are not held responsible forever and ever. If in the plan, a Good Samaritan says, as an example, we expect to reduce cadmium by 20%, copper by 30%, lead by 10%. If those conditions are met, the EPA calls the project a success, and the Good Samaritan is relieved of permanent liability. If the Good Samaritan does not meet the conditions of the permit, then the liability waivers are gone. Under a scenario where a Good Samaritan does not meet the conditions of the permit or makes the conditions worse, they are held reliable. They can be fined. They can be sued by downstream users. All of the usual liability issues that arise around pollution can come into play if the Good Samaritan does not meet the conditions of the permit. NEPA is required at these projects, so there will be a NEPA project, a process associated with each one of them. But of big importance is the relaxation of water quality standards. Again, under current laws, you basically have to clean up 100% of the pollution. If you're, again, an industry that creates a pollution source, you have to clean that up to effectively 100% purity before that water can go on downstream. That works well when you have active wastewater treatment, like up at Gladstone, where there's infrastructure and electricity. But the types of projects that Good Samaritans are likely to perform are going to be passive wastewater treatment, and those types of passive systems will never meet Clean Water Act standards. They just can't. And so we know going into one of these projects, we're going to fail under the Clean Water Act because we don't get to 100% attainment of those water quality standards. But our contention is, of course, isn't it better to remove some of the metals than none at all? And under today's laws, it is none at all. One to point out, because it dovetails into Good Sam legislation, that the infrastructure law that was passed back in November, really a major investment in infrastructure by Congress, included the creation of a new abandoned mine lands program administered through the Department of Interior. Again, our thanks to Senator Heinrich from New Mexico. He was the senator who included that in the infrastructure bill, and now that that is law, we do have a new abandoned mine land program through the Department of Interior. And what it does is it authorizes $7 billion with a B dollars be spent by or authorized by Congress to address these draining mines over the course of the first 3 years of this program. So the program is not funded just yet. The authorization was given through the infrastructure law, but it hasn't been funded yet. That has to be done through congressional appropriations. That can happen, as an example, the Build Back Better bill that the Biden administration put forward included money to go into this abandoned mine lands program. It can also happen, as an example, if 1872 general mining law reform were ever successful, whereby royalties would be collected from the mining industry. In that situation, those royalties collected would go into this abandoned mine lands fund so that we have the funding component. That's all well and good. It's great to have the money in the bank if we can get it in the bank. Unfortunately, the regulatory and liability issues remain in the way. And you can have all the money in the world, but if there is no legal mechanism to put that money to work, it doesn't do much good. Good Samaritan legislation is that legislation. That is the legal mechanism that we need to couple with this infrastructure funding so that we can once and for all address the draining mines in this country from abandoned sources. So that's what I have for right now. We're very, very hopeful that we can get Good Sam passed finally. I think this is arguably our best shot at it that we've ever had in the last 20 years. And again, the list of current Senate sponsors for me speaks volumes about the type of law that we hope to create. So I wanted to leave plenty of room at the end here to take questions from people. I know this gets a bit confusing, and it's a topic that we've talked about at this conference before. I spoke about it a couple of years ago, but we've advanced. We have a bill now. It is moving its way through the congressional process, and this is the one we hope to get passed. So I wanted to make sure and save time for questions from anyone.
Hi. So I heard about the Torero mine in Pecos and that they were able to clean it. The Pecos was able to clean it up as a community so that it wouldn't become a Superfund site. And I was wondering how that was possible because you listed a bunch of barriers to that. And so I was wondering how that was able to happen.
Yeah, I don't know the exact details on that one in particular, but I can tell you this. A great deal of the cleanup that occurred were at non-point source related issues. Again, waste rock piles that needed to be moved or water and waste rock piles that needed to be addressed. I'm not positive, and I welcome input from others, that there is an active or an ongoing business associated with the Torero mine that might have done some water treatment as well. So mine cleanups can occur. Again, they're happening, but really the crux of the issue and the biggest sources of metal loading are often from these draining mines, and that's the rub. So what I know of that site in particular, it was cleanups that were performed under current legal laws, or it was an active owner who was doing some of the cleanup. I'm not sure I would consider that a true abandoned mine like some of these others we're talking about. Good question.
Howdy there. It's great to hear that there's progress on this. I was wondering if you could speak to the passive water treatment of mine waste. What would that look like? How are we going to harness nature to clean up abandoned mine lands versus having an active treatment site that has chemical and biological processes that do it in a contained environment?
Yeah, great question. Certainly there are students in universities all over the country, grad students who are working on improving passive wastewater treatment for mine waste in particular. When you treat mine waste, we call it acid mine drainage. So it's the acidity of the water really that is the issue. Under conditions of acidity or low pH, those metals become dissolved, and it's in their dissolved form that they are most likely toxic to aquatic animals or terrestrial animals like us for that matter. So at a passive treatment, you have to address the acidity of the water first to really start to remove those metals. That can happen, as an example, by doing nothing more than running that wastewater over limestone to change the pH and raise the pH and lower the acidity. So that's one example. And then potentially downstream from where the pH is addressed, then you might have settling ponds. These could be engineered wetlands or actual concrete settling ponds, whatever the case may be. But once those metals are re-solidified in a more neutral pH environment, if the water is slowed down, like behind a settling pond of some sort, those metals can fall out into the bottom of the settling pond and then not be transported downstream. So that's the idea behind these. Again, it's adjusting the pH with limestone and something to slow the water down so that the metals can settle out. Additionally, there are also plants that do uptake of these metals, and as these engineered wetlands often have specific species of cattails or some other plants in them that do really good job of uptake of these metals and sequester it in the tissue of the plant as opposed to flowing downstream. But again, under that scenario, you're not going to meet 100% attainment of water quality standards. So while you may remove metals with one of these passive systems, you have failed under the Clean Water Act. And as such, under today's laws, you can be sued for failing to meet Clean Water Act standards, even though you have made some improvement in water quality.
Hey, Ty,
Hi,
great
Melissa.
presentation. Potentially thorny question for you to wake everybody up, but so
I'm ready.
is there anything in the Good Samaritan legislation that would protect the Good Samaritans from liability associated with something like the Gold King mine spill, where it's an inherently risky activity doing mine remediation? And so is there something that would help? It was EPA contractors trying to clean up a mine that caused the Gold King mine spill, but is there anything in place in the legislation that would protect those that are trying to do that type of work?
Yeah, in particular, again, Good Samaritan will authorize low-risk projects. And as I already noted, those would be projects that don't have any sort of backed up water behind a collapsed adit. It's important to note, and I didn't say this in that slide when it came up, but EPA has full discretion on which of these sites they want to authorize. So once the legislation were to pass, again, the state mine remediation agencies or a nonprofit or a non-governmental entity could apply for one of these permits, and it is fully discretionary by the EPA which projects get approved as one of the 15. So I would argue that for one of those scenarios, EPA would simply say, nope, this is not the kind of project we want to do. It does not meet the criteria of being a low-risk site, and it would be denied. Anybody else? I will say one more thing before I go. Passing federal legislation is a monumental task. If anyone pays attention to politics, it's even harder today. We have a real chance at passing Good Samaritan legislation, and thankfully, the members of Congress, in particular senators from the West and our senators in Colorado and New Mexico, are fighting for this legislation. If you're interested in doing any advocacy, please contact your congressman or woman, your senator, and say, I support good legislation, and in particular, contact your two senators here in New Mexico and ours in Colorado and say, get this done. Make this a priority. It is time to get Good Samaritan passed. So there's a little opportunity for some advocacy for you. Any other questions? Very good. Thank you all for the time.
All right, well, thank you. It's my pleasure to welcome our next speaker. Shelley Lemon has worked for the Surface Water Quality Bureau for the New Mexico Environment Department for over 17 years and is currently serving as chief of that bureau. I also want to say it's been an honor to have Shelley join the planning committee for this year's conference and having all of her wonderful contributions to help make this conference a success. So Shelley, I'll turn it over to you.
Thank you, Mark, and welcome everyone. We are super happy to have everyone here at this conference. I am going to be giving a presentation about our river stewardship program through the New Mexico Environment Department, and it's an opportunity to help fund projects that we've been talking about to improve water quality. All right. So the goal of the River Stewardship Program is to fund projects that enhance the health of rivers by addressing the root causes of poor water quality and stream habitat. The River Stewardship Program projects are collaborative with local volunteers, New Mexico contractors, federal, state, tribal, and local governments. And as such, the River Stewardship Program invests in local economies and provides benefits for recreation, tourism, and agriculture. Some of the objectives of the River Stewardship Program are to enhance the economic benefits of healthy river systems, to restore or maintain the hydrology of streams and rivers, and to provide match that is required to leverage our federal grants to ensure that federal funding continues to come into New Mexico. The River Stewardship Program is an integral part of our non-point source management program, and NMED receives federal funding for non-point source pollution management, watershed restoration, and our wetlands program. And the grants require state funding in order to receive the grants. So this River Stewardship Program helps to provide that state funding to offer that matchup for the federal dollars that we receive. With over 45% of assessed streams and surface waters in New Mexico listed as impaired for one or more pollutants, and increasing demands for clean water and increasing stressors related to climate change, there is definitely an abundant need to conduct river habitat and improvement projects in New Mexico. So how do we award these projects through the River Stewardship Program? The projects are awarded through a request for proposals process, which includes planning, permitting, design, construction, and post-implementation monitoring. The funding term is usually 3 to 4 years. And the river stewardship projects, like I said, are selected through a competitive process that complies with our state procurement rules. We have evaluation criteria to ensure that these projects are technically sound, community-based, and stakeholder-driven. The projects occur in and around surface waters of the state of New Mexico, which include rivers, streams, wetlands, playa lakes, floodplains, and riparian areas. Like I said previously, they're collaborative projects and include tribes, pueblos, state and local governments, not-for-profit businesses and for-profit businesses. We have state funding. Usually the New Mexico Environment Department requests about $1.5 million in capital outlay funding each year for this program. We don't always receive it, sometimes we do. In this past legislative session, in the special legislative session in December, we were appropriated $10 million, one-time appropriation, which this funding will expire in June of 2025. So I'm going to talk about the RFP that we just released on the next slide. So the New Mexico Environment Department just released a request for proposals on May 26, 2022, and we're seeking proposals for projects that improve surface water quality and river habitats and also minimize wildfire risk statewide, help with climate change and all of those stressors that we know exist in our current surface waters. We have, through this request for proposals, about $10,375,000 available for funding these projects. I will say that no match is required for these projects because this funding is state funding that's being used for our federal grant program. So no match is required. And any state and local agencies, including cities, counties, state governments, soil water conservation districts, for-profit and not-for-profit organizations and tribal governments are eligible to receive this funding. Successful proposals will demonstrate a clear need for restoration actions based on a planning document. They will demonstrate the support and commitment of the community and applicable stakeholders. Successful projects describe a scientifically sound and sustainable project and provide clear, measurable, and achievable goals and objectives, and propose a budget that is justified, fair, and provides a good value for the project. The projects will have a start date around February 2023 and will be completed by June 30th of 2025. Offerers can submit proposals electronically to the New Mexico General Services Department, State Purchasing Division's e-procurement system. And the RFP is available online. The URL is up on the slide. And proposals are due no later than 3 p.m. on Tuesday, July 26th. So this provides a table of current river stewardship program projects. They are available on our website through the Surface Water Quality Bureau. And this table shows the 9 projects that were funded in fiscal year 2020. And they range in cost from a little under $60,000 all the way up to $457,000. Through this slide, if you go to the summary report and you click on that, it'll take you to more detail about the project. So you can see, more information. There's the project proposal, who are the collaborators on the project, what are the costs associated with the project that are broken down. So again, this is all available on our website, but it shows different types of projects. We have spring restoration, Animas River habitat enhancement, and bank stabilization. And we're doing some other restoration projects throughout the state of New Mexico. This other slide is the list, the most recent list of projects that have been funded through our river stewardship program. They are 12 projects that were funded in 2022, so just this past year, FY 2022. So we just entered into 12 new contracts, and they are all in the design status because they are new contracts. And again, you can click on the summary report if you go to our website and find out more information about each project. I'm going to provide a couple of overviews of two projects of the type of projects that we fund with our river stewardship program. So this first one is wetland and stream restoration of Lower Jaramillo Creek in the Valles Caldera. And Jaramillo Creek and East Fork Jemez River do not meet water quality standards for nutrients and turbidity. So Keystone Restoration Ecology is going to try to restore some of that habitat to increase the nutrient and sediment processing capacity of the stream and the adjacent wetlands. So the picture on the left is Jaramillo Creek. You can see that it was down cut and in size so that when there is flooding, the flood doesn't overflow into the floodplain. And as a result, the adjacent wetlands had dried up. And so the picture on the right shows a newly constructed ponded area to reconnect the creek with its adjacent wetlands, and that's helping to re-wet that floodplain and re-wet those wetland areas to help with nutrient and turbidity processing. This second project is restoration of trout habitat on the Cimarron River, and it was originally started with river stewardship funding, and then the Office of Natural Resources Trustee entered into a settlement agreement with an oil company after a 2016 tanker spill that spilled diesel directly into the Cimarron River. The Office of Natural Resources Trustee got money from the oil company, and so we use that money to supplement this project and increase the river miles that we are restoring with this project. So it's a combined funding source through the river stewardship program and also through the Office of Natural Resources Trustee. And we are currently restoring 1.3 river miles on the Cimarron River. And it's basically improving, it's creating more complexity of the Cimarron River, creating habitat for the resident brown trout and overwintering areas for the trout, and also providing refugia when it's low flow conditions. So on the right, you can see that the Cimarron River was not very complex. It was pretty much a straight stream channel. It is a special trout area in this reach. It's in the Cimarron River State Park, which is managed by the New Mexico Department of Game and Fish. So the project is intending to create more complexity, changing up the width to depth ratios, putting in some large woody debris and other structures to provide more complex habitat for the aquatic life in the stream. The pictures on the left show the construction and also post-construction of those rock veins that cross the channel. All right, so this slide is basically talking about frequently asked questions that we get. So A lot of times, with the river stewardship program, people ask, what is the minimum or maximum project amount that we will fund? And really, we don't have a minimum or maximum project funding. Like I showed on the previous slides, projects historically or currently range from about $60,000 all the way up to $460,000. However, with our one-time $10 million appropriation, which is 10 times what we normally propose, we're looking to receive, bigger projects, higher cost projects, or more projects that we will be funding with this RFP that is currently out for proposals. What kind of projects will be funded? Any projects that improve surface water quality or river habitat within a waterway or surface water, or its associated riparian area and floodplain through on-the-ground activities. So we're looking for active on-the-ground activities and restoration projects or enhancement projects. Both government lands and private lands are eligible. So if your water that you're thinking of is on government or private lands, you can apply for river stewardship program funding. However, projects on private lands must pass an anti-donation clause review and also will require a private landowner agreement with NMED to proceed. So it's a little bit more complicated, but it is definitely doable and achievable if we have the landowner's cooperation, which we definitely want if we're going to be spending money on these projects. So what costs are eligible for funding? It pretty much covers the gamut of a project. So from planning, engineering designs, permitting, construction, pre and post implementation monitoring, supplies that are permanently affixed to the project or expended during the term of the project, hourly wages for direct work on the project, and any equipment rental that you might need in order to conduct the project. You can find out more information on the Surface Water Quality Bureau's website, which is listed at the bottom of this slide. And then I have some contact information. Obviously, you can contact me, but we do have a river stewardship program coordinator. Her name is Kate Lacey. She couldn't be here today, which is why I'm standing in for her. And her email address is catherine.lacey@state.nm.us. And also Abe Franklin, who also couldn't be here, but I believe is watching virtually. He is our watershed protection section program manager. And the river stewardship program falls under the watershed protection section. He also helps to manage our non-point source management program. And Abe's contact information is abraham.franklin@state.nm.us. You can also sign up on our Surface Water Quality Bureau webpage to receive email updates. And the link, the URL is listed at the bottom of the page. So with that, I will open it up for any questions about the river stewardship program.
Good morning, Michelle.
Good morning.
It's good to see you in person.
I know.
My name is Carol Clore, and I'm with the Lee Hammond Domestic Water Board. If we apply for this, do you have to be a mutual? Because we are a nonprofit cooperative. Would we be able to apply?
Yes, you should be able to apply.
Okay, thank you. We probably will.
Yay, great. Do we have any other questions? All right, well, thank you so much. And I look forward to getting your proposals.
Thank you so much, Shelley. We'll be taking now a little break. I would say, let's see, just to give everyone enough, I think we can still stay on schedule. So We'll be convening back with presentations again at 11 o'clock. So enjoy some coffee, water, orange juice, scones, stretch your legs, and we'll be back with presentations shortly. All right, everyone. We'll begin with the rest of our morning presentations. So I'm thrilled to introduce Alyssa Richmond as our next speaker. Alyssa is a botanist, river enthusiast, and avid hiker, originally from the Appalachian Mountains of West Virginia and lives in Aztec, New Mexico. With a bachelor's degree in environmental science and geospatial analysis from Davis and Elkins College of West Virginia, she has extensive experience in natural resources management through her years working with the National Park Service at a New River Gorge National River and Chaco Cultural Canyon Park. She has served the San Juan Watershed Group and is an employee of the San Juan Soil and Water Conservation District of New Mexico. Alyssa, come on up.
Get this adjusted for height. Can everyone hear me good? All right. Well, thank you so much, Mark, for that introduction. I want to thank New Mexico Water Resource Research Institute, specifically Mark Shealy and Jeanette Torres, for doing all the coordination for this conference. It's been so great to come back to this conference after a COVID break. But I definitely am very excited to be able to share with all of you our updated results from our sampling last year that really looks at answering the question of who pooped in the river. Honestly, not going to mince words with this presentation. I'll be able to go along right with it and keep it real. Before I start, I do want to give a shout out to Melissa May. She has been an excellent colleague, mentor, and friend, and she has been involved with this research since its very beginning in 2013. And without her, the Watershed Group would not be where it is today, and I wouldn't be up here talking and giving this presentation or updated sampling. I also want to give a shout out to our funders for this research, our latest sampling as of last year, the New Mexico Environment Department Surface Water Quality Bureau, which we use 604B funding for the project. And we also were able to use match funds from BHP settlement, BHP Bulletin funding. So to give a little context to you all, I'm sure you guys have heard about us in one way or another, but the San Juan Watershed Group is a group of citizens and local agencies working to improve water quality throughout the San Juan River and watershed. To do this, we do a very multi-step, multifaceted approach. We do watershed, water quality research, watershed planning, projects to address non-point source pollution. Shout out to Ty Churchwell for the awesome presentation talking about the Good Samaritan Law and the differences between point and non-point source pollution. And we also do community outreach and education, which throughout this specific project we've been working on for over 10 years. We'll be able to give you a little bit of information about all of those of what we do. So to give you guys a little bit of context on why we're even asking this question on who pooped in the river, as Shelley pointed out that several reaches of these waterways in New Mexico are on the impaired list, 303D list for the Clean Water Act. The San Juan Watershed is no different. A lot of stretches in the San Juan Watershed of New Mexico have been on the impairment listing at one time or another. Specifically for E. coli, which is the main focus of this presentation, all of the waterways that you see with purple lines have been impaired for E. coli at one time or another. Specifically for the San Juan, it has been first identified for an E. coli impairment since 2005. So specifically the La Plata River, the Animas River, and the San Juan River. This is from New Mexico Environment Department's surface water quality sampling back in 2013 and 14. And for this E. coli impairment, our data from 2013 and 14, the first study looking at who pooped in the river, really fed into this impairment listing on these waterways. just to show how the impairments have changed over the years. So NMED went back out in 2017 and 2018 for the new cycle of 303D listings, and there have been some changes. So from their sampling results on the Animas River and in New Mexico and on the San Juan River in the upper stretches, upriver of Farmington, they were delisted for E. coli. They did not find enough exceedances of E. coli following their water quality standards at that time. However, the lower stretch of the San Juan River, downriver of Farmington, still, and La Plata River still maintains to be impaired. And the Gallegos Canyon, Shumway Arroyo, and Stevens Arroyo were sampled for the first time through that sampling effort and were listed for the first time for E. coli back in 2020. One of the things that E. coli is really good to be able to look at is it's a fecal indicator bacteria. E. coli, it comes from the gut of all mammals and all cold-blooded animals, but they are an indicator of more harmful bacteria that can be present in the waterway that can cause gastrointestinal illness. But E. coli itself does not look at where that fecal bacteria is coming from. So this is where microbial source tracking comes in. Microbial source tracking is the science and method of being able to look at different species of bacteria that are known to have evolved DNA segments that reflect its host. So we're able to look at, through DNA analysis or PCR analysis, where the specific bacteria we're looking at is coming from. For the sake of this study, we looked at a specific species of bacteria or genus of bacteria called Bacteroides. That specific bacteria has been confirmed over several studies to be able to look at different host organisms of fecal bacteria. So I wanted to give you guys a little bit of background on why we did the updated sampling in 2021. So back in 2013 and 2014, we did our first microbial source tracking study to look at the fecal bacteria in the river in a way for us to know what are the most efficient and beneficial ways to address the bacteria pollution. So in 2013 and 14, we wanted to look at figuring out what the host sources and host animals were contributing the most bacteria to the river. Just a second, let me get my slide. We wanted to be sure on who pooped in the river. We wanted to make sure that the results that we were seeing were actually reflecting what was on the ground. So during that first study, we did a couple of QA/QC requirements. We looked at different ways to be able to look at the data. We did 2 different types of source bacteria to look at human sources. And we also looked at a specific virus that is specific to diets with high green chili, which is the most Southwest scientific thing I've ever heard of in my life. So we definitely wanted to be sure that whenever we were looking at these host organisms, which for this 2013 and 14 study, we looked at humans, we looked at cows, we looked at horses, and we looked at dogs. So we really wanted to be able to look at, with that double up of QA/QC, where this bacteria is coming from, and if we're able to, how, when, and where, and how much are we seeing it. So back in 2013 and 14, we really prioritized a lot of fewer sampling locations with a higher sampling frequency. We sampled for once or twice a week between April and October for both 2013 and 14, so that we can both look at how that changed over the water year, both spatially, where our sampling locations were, and temporally with water flows throughout the river. And in 2021, after those results, we wanted to be able to see, is anything changed? Is human poop still in the river? Where and how much? We're able to look at hot spots of where it could be coming from if it is still present. And one of the assumptions from the 2013 and 14 study was that wastewater treatment plant outflow or point sources were not contributing to the human source numbers we were seeing in the river. But we wanted to be able to fill that data gap in this latest study to be able to definitively rule that out. So for our sampling sites from 2013 and 14, again, we prioritized fewer sampling locations, higher sampling events to be able to see what the host organisms were. So we had 3 sampling locations on the Animas and 2 on the San Juan. We had on the second year in 2013, we added the sampling location right below the confluence of the Florida River in Colorado. We had a sampling location for both years in Aztec. And then we had another sampling location right before the confluence of the Animas at Boyd Park, another sampling location at right on the San Juan, right before the confluence of the Animas. And we had our last sampling location right at the Hogback, the jurisdictional boundary of the Navajo Nation. So the results, briefly going through this, that we can go into our brand new update from 2021. So from those 2 years of sampling, this graph will show you what is the presence and absence of the different host organisms that we were looking at. So the green bar here on the graph looks at human source. The red bar looks at ruminants, which after the first year, cow really wasn't very sensitive. So we combined into ruminants, which includes cows, deer, elk, and sheep. Counts for all of those, both wildlife and domestic sources. And then the blue bar here is for birds. So one of the things that we were not surprised on was the near consistent ruminant sources. Typically, we had between 90 to 100% positive of ruminant sources of bacteria, which wasn't really surprising. There's a lot of wildlife throughout the landscape, but there also is a lot of domestic wildlife, cattle, and your grazing activity that is done within the riparian corridor. So that's something that we really expected. Human was not as much expected as we saw. So on the Animas River, our presence of human source was typically between 60% between both of our sampling locations. On the San Juan, our presence for human source was between 90 to 95%. That was definitely something that we did not expect. It was a way much of a shocker. As for birds, we really, between all 4 of our sampling sites, it was pretty consistent between 30 to 50%. There's not really much that we can do about bird bacteria unless we have no-fly zones along the river, which is not very practical. So as for looking at, okay, we know what the presence of the specific bacteria is, but when we're talking about how much, what does that look like? So this graph specifically looks at human fecal bacteria. Back in 2018, we worked with Lumen Ultra Labs that did all of our analysis for all of our microbial source tracking. I forgot to mention all of our E. coli samples were sent to the Farmington wastewater treatment plant for analysis. But this was the average, different methods for averaging all of our human source samples between our about 50 to, over 70 different samples that we collected back in 2013 and 14. And one of the things that we saw was that on the Animas, it was actually, the presence was kind of high, but the quantity was pretty low. Something that was good to see. But one thing that was definitely a surprise was that between our sampling location above the confluence of the Animas on the San Juan and on the San Juan at the Hogback, we saw a 6-fold increase in human source bacteria. And to be able to give some context to you on whenever we first did this study, we weren't entirely sure on what is the threshold of where these numbers are a concern. Is it 100 copies of human source bacteria? Is it 1,000? Is it the average that we saw at the Hogback at between 23,000 and 26,000? So we did some digging, and Stanford University back in 2016 did a study that kind of set the benchmark at 4,200 copies per 100 milliliter for this specific bacteria was the illness benchmark for if you have 1,000 swimmers in the river, the high probability is that 30 of them are going to come for a gastrointestinal illness. And so we use that 4,200 copies as the benchmark of that's where we need to be concerned. So this was on the San Juan above the confluence of the Animas, really wasn't above that benchmark, but it got a lot higher as you went downriver to the Hogback. But one of the things that this study didn't tell us on where is it coming from. So after this study, we worked with all of the stakeholders in the San Juan Watershed Group to look at what are the potential sources that we can investigate later on. And so throughout those 8 years, we really looked at doing a sampling study that had the inverse approach to give us an update. We wanted to do a study that would be able to look at a higher density of sampling locations and a lower frequency of sampling events so that we can look at hot spots of where this bacteria could be coming from. When we did this updated study in 2021, we had the assumption that bacteria was still in the river. And we wanted to be able to look at where it was coming from. And this is why we do the study, to be able to investigate that. So to be able to look at this map shows all of the sampling locations that we did, about 17 in all throughout this stretch of the river. To be able to rule out if wastewater treatment plants were actually contributing to the surface water samples we were looking at, we sampled from the outfalls of Bloomfield Water Reclamation Facility and the Farmington Wastewater Treatment Plant. We looked at right above the outfall of the Bloomfield Water Reclamation Facility. We sampled on the San Juan in Bloomfield. We sampled at McGee Park. We sampled at right at the river where B Square Ranch is, to be able to capture a potential septic system source that we had heard through our stakeholders. We also did a sampling location at SJ Farmington, which was our legacy site from the 2013 and 14 study. We looked at the sampling location on the Animas from the previous study at the mouth of the Animas to contribute those. We looked at Bisty Bridge, and then downriver, from there, we really prioritized our sampling locations between Farmington and the Hogback, because that was where we were seeing the highest uptick in human source bacteria. And we also sampled from the La Plata River, Stevens Arroyo, and Shumway Arroyo, to be able to look at what those contributions could be, especially since those waterways are still impaired from NMED. And for this study, we continue with the same trend of last year. We sampled for E. coli to be able to provide information to NMED for their 303D listing, but also we only specifically sampled for human source, and we went through Lumen Ultra Labs again to be able to do that analysis. And I also want to give a shout out to Desert River Guides. Half of these sampling locations, we were on a raft where we had about 16 volunteers all together join us for 4 sampling days. We sampled once a month for 4 months between August and October. So we definitely wanted to be able to prioritize this hotspot analysis rather than general water flow trend. So getting into the update. How is E. coli looking? These results are actually very similar to the results we got from 2013 and 14. About 50% of our samples were over the single grab exceedance limit for NMED, which is that red line right there. On the x-axis is our sampling locations. The y-axis is our E. coli concentrations. I do realize that the way that our sampling locations are listed is actually a reflection and inverse of how the locations were put on the map. So just make sure to know that SJ Farmington is starting from the upriver section and going down. So for E. coli, we definitely saw about 50% of our samples came over the single grab exceedance limit. The only sampling location that didn't have any exceedances was the La Plata River, but the La Plata River flows were very low whenever we were going and doing our sampling, which could have contributed to the results that we were seeing. But overall, the sampling locations that we were seeing the highest amounts of E. coli was from Shumway Arroyo and Stevens Arroyo downriver of the confluence of the Animas. But generally we're seeing overall an increase in E. coli concentrations as you go downriver. So going on to the human source numbers. So this graph is set up in the same way as E. coli with sampling locations on the x-axis and our human source numbers on the y. This is really zoomed out to show all of our sampling results, including the wastewater treatment plant outflows. As you can see from here, for wastewater treatment plant outflows, they came in very high numbers. But as for the actual implications that had on surface water samples, it's not very much. There wasn't really any significant increase in our downriver sampling location surface water numbers, which is good to see. And even though our results for the wastewater treatment plants were high, that can be an inference that the treated sewage coming out is not really reflective of a human health risk. Because of human source numbers and the analysis that's done, it's looking at DNA. So it's looking at both live and dead DNA. We're not able to see how much of this human source bacteria is actually alive and actually having a human health risk. So this really indicated to us that the numbers that we're seeing coming out of the wastewater treatment plants really degraded very quickly once they met the river and didn't really impact our results on the downriver sections. There we go. So looking at taking out our wastewater treatment plants. So this is taking out our wastewater treatment plants and looking at only our surface water samples to get a good zoom in on what those concentrations are looking like. Any brown dots here that are along the the x-axis, that is non-detects. That is the bacteria wasn't detected at all. So in comparison to our 2013 and 14 study, one of our outlier locations on our hogback sampling location was over 100,000. Our highest result that we had for this round of studies was just over 4,000. So overall, there has been a great reduction in the amount of human source bacteria that we are actually seeing, which is a very, very good sign. And one of the things that we definitely did notice, though, is that it is still present in 29% of our samples that we took. Only one of our samples was over that 4,200 benchmark, that was coming in the Fruitland area at our SJ Fruitland site. And also our tributary samples from the Animas, the La Plata, Chamoy Arroyo and Stevens Arroyo did not have any detects of human source bacteria, but they did have high E. coli numbers, which shows that there's another host organism playing an effect there. So to go into more details on the trends that we were seeing on our sampling days, to look at all of our sampling locations and how things changed. So on our first sampling events on August 4th and 5th, we had a stormwater event that came through where we had on August 2nd that shot up our CFS, our flow on the San Juan to over 3,000 and then went back down. So we had a high stormwater event, and we did see that all of our E. coli numbers, except for coming from the La Plata and Stephen, actually just from the Animas and the La Plata River, were all over the single grab exceedance limit, that red line that you see there at 410. And that could be due to the actual high flows that we were seeing the few days before. The river was really chocolate milky at that time. It was really turbid, which really could carry more bacteria in the river at that time. And overall, we're seeing that our samples results for human source were non-detects, except for between the confluence of the Animas and Lions Park, which is right before Kirtland. That was the only time that we were seeing any spike. I did also want to mention before I move on, though, just to be able to throw this caveat in there, that on August 5th, our human source samples that we shipped to Florida for Lumen Ultra Labs did not make it between the 24-hour time limit and did sit in FedEx for the weekend. So that really degraded our quality for those samples. After talking with Lumen Ultra after that, all of our samples from those days, which is downriver of Lions Park and our tributaries, they all came back from non-detects. Because of that long wait in the box, there's really no telling on how those samples actually reflect what was in the river at the time. But overall, if there were high concentrations in human source bacteria, there still would have been a chance it would have picked it up. So if there were any, the chances are it was pretty low. Going on from August 25th and 26th, this one was a much less turbid day. The water was a lot clearer. We did have a lower flow throughout the San Juan River, but we had a higher Navajo Dam release, which could have diluted the concentrations we were seeing a bit. This was the general trend that we were seeing from the 2013 and 14 study. This shows really that most of our E. coli samples, except for our sampling location and water flow, were all below the single grab exceedance limit. And the only time that we really had any human source numbers pop up for presence was starting at the Fruitland area and going down towards the hogback. So a completely different geographic area that we were seeing in our last sampling day. In September, again, the flow was a little bit higher. We did have a storm event on the 28th, the day before our first sampling day, and then the night of September 29th, which did increase our flows a little bit and our turbidity. Overall, the trend for E. coli was that once it got past the confluence of the Animas is where we started to see an increase overall going down river for E. coli. But interestingly enough, the E. coli results that were low and not over the single grab limit, that's where we were seeing the human source uptick starting at McGee Park and going downriver towards the confluence of the Animas. The actual date on the top is wrong. These are from our October 27th and 28th sampling locations. We actually did not intend to collect human source results or samples from the study, but we were able to scrape together some extra funding and really happy that we did. These were of this sampling event. This was the only one of 4 of the sampling events where all of our human source numbers came up positive. And this was the only time throughout all of those samples where we had over the illness benchmark. So definitely one, and this was the only time that in between Bisti Bridge into the Hogback that our human source numbers really matched the trend sort of our E. coli numbers. Other than that, there was really no correlation to our human source and our E. coli. So finally, the conclusions from all of this. One of the questions we wanted to answer was, has E. coli and human source bacteria levels changed since 2016? The answer is yes, and very, very good indicator. Our E. coli numbers are still high. They're still very high. But again, about 50% of them were over the single grab exceedance limit, but human source levels in comparison to where they were at from an average of 25,000, this year it was on average between 1,000 to 4,000. Over the past 8 years, that really shows a great reduction in the amount of human source bacteria contributions we're seeing. The next question that we wanted to look at are wastewater treatment plant outflows contributing human source levels. The indication is no. Even though we were seeing high numbers from the wastewater treatment plants, we did not see any correlating spikes in the downriver sample, which really shows that after treatment from the wastewater treatment plant, those DNA that is detected really degrades rather quickly and does not have a human health risk. There is a method to be able to look at telling apart for those wastewater samples what is dead and alive bacteria, and further sampling with additional methods could be able to look at that. But because of these results, it really doesn't show that it may not be a priority. Okay, when, where, and how much? Tributaries did not detect any human source, but high E. coli, which really indicates sources from others. Again, 29% of our samples were quantifiable for human source. About 50% of our E. coli numbers were over the single grab. And being able to look at, does this rule out any human source hotspots? Not consistently. On different sampling days, we had different sections of the river that had a positive for human source. So that really indicated that there was really no specific area for future work to be done. Any work to be able to address human source bacteria has to be done on a watershed scale. And this really pointed at that even though human source has gotten a lot better, there's still work to be done to address the high E. coli numbers that are coming from other sources, which from our 2013 and 14 sampling really looked at ruminants could have been one of those big components of that. So now looking into kind of what are the reasons that there could have been a reduction in human source bacteria. So over the past 8 years, the San Juan County and the city of Farmington have done an excellent amount of work to address sewer infrastructure, which we think really had a key factor into these reductions. So back in between those 8 years, Farmington Wastewater Treatment Plant did an expansion of their facility to be able to increase the capacity of how much waste they can process. They decommissioned the Harper Valley Wastewater Treatment Plant, which was not meeting their discharge permit regulations, and did a sewer extension down to Kirtland to cover that wastewater treatment plant, which that was less non-point source pollution that could have been coming from. The Central Consolidated Schools on Line Lagoon was decommissioned and also put to the Farmington Wastewater Treatment Plant. And then from there, there was a lot of increased training and certification of septic haulers and pumpers who are the frontline workers for septic systems. So there's a lot more people that had that got more training on being able to work in the industry. And then finally, the Watershed Group, we did a lot of work on septic care and outreach. Now, we could be able to say that we wanted to pat ourselves on the back for this. Don't really know how much the water, we can be able to do that, but we do know that even though that human source numbers are less, there's still work to do. So in between that time, we've done a lot of septic system care and outreach to San Juan County. We did an RV dump station signage improvement campaign throughout San Juan County to help reduce illegal dumping and support economic recreation economy. We did a liquid waste training program in 2021. And I think really one of the biggest proponents of this is City of Farmington sewer infrastructure. But there's still work to be done. One of the things that we've noticed is that when people have failing septic systems, oftentimes they know it, but they can't afford it. And that's where it becomes an equity issue, an environmental justice issue, where if there's able to be a septic share cost share program to be able to have a financial cost share to address those issues, that can further be an incentive to be able to improve septic systems and reduce non-point source pollution. And finally, just because there's a lot less human source, again, there's more work to do. Our E. coli numbers were still high. And from our 2013 and 14 study, about 90 to 100% of the time, our samples were positive for ruminants, which could be wildlife and livestock. So the San Juan Watershed Group and our partners have been doing a lot of work, especially on the Animas River, to help address that, working with ranchers and producers to improve soil health, being able to do livestock exclusion fencing to keep livestock out of riparian areas, doing plant runoff buffers, and improving irrigation efficiency so there's less runoff. So there's a lot more work to do, but overall, great work, everyone. We've seen a really great improvement. And with that, I will take your questions.
I'll ask you a question.
Go for it, Andrew.
Well, this will put you to the test a little bit, I think.
Sure.
Do you recognize any shortfalls in your study that maybe weren't addressed that you wish if you could go back or do another study that you could shape something a little more specifically around other areas? What would those shortfalls be and how would you maybe address them in the future?
That's a really good question. I feel like one of the things that would have been good for us to include is that for this specific study, because of the human source numbers we were seeing, we only sampled for human source for N. coli. If we were able to go back in time and also to include some ruminant source samples in there to be able to look at a comparison for those, that would give us a little bit more information. So that's definitely something that I would change overall. One other thing that I would be curious to see is that back in our 2013 and 14 sampling study, the Animas did have about 60% of those samples for human source, which we saw no detects for human source in this study. So I probably would have added a little bit more sampling locations on the Animas to be able to really capture that. But yeah, I feel like that's really all that I can think of at the moment. Yeah, thanks. Yeah. Gotcha. I see what you mean. So we didn't really capture any sampling during the winter months since our latest was in October. And for this, just with the San Juan, because of Navajo Dam, our temperatures are pretty regulated. They're pretty monoculture wide. They're a lot cooler than naturally because of the cool water that comes from Navajo Dam releases. So as for temperature, we really couldn't definitively say if that really had an impact, but we could say that typically if we had a stormwater event that came through and increased, the flow beforehand, we did see higher numbers than in comparison to flows that were really determined by Navajo Dam releases. So we saw an increase in stormwater events and concentration, generally a decrease in concentration from maintained flows from the dam. But as for seasonally, yeah, no other determinations from their samplings from that. Are there any questions over Zoom?
Questions, but Dennis in the chat wants to say terrific research.
Oh, thanks, Dennis. All right, thank you guys so much, and looking forward to the rest of the conference.
Thank you, Alyssa.
Yeah.
All right. Well, we have our last morning presenter here before our luncheon begins. And it's my pleasure to welcome Dr. Carol Clower. Dr. Carol Clower is currently a board member on the Lee Hammond Domestic Water System. She researched 52 years of minutes and wrote a book about the origins, political intrigue, and development of the system that her husband and 4 other men started. Carol, welcome to the podium.
Wow, I'm glad we're tall, huh, Alyssa? I want to thank you for coming today. I'm just so pleased to see that you're here because as you'll see in this study, it takes people to make a dream come true. And in your heart, you have the right thought, serve your community and give back. And that's what I do in my life. Thank God I'm retired and have enough money to run around and do it. I have one of my best friends with me, Aaron Lee, and he is the director of the Lee Hammond Domestic Water Association. He's the vice president of the New Mexico Rural Waters Association, and he's the president of the San Juan Rural Waters Association. He is also a licensed 4 operator, which are hard to find, but we found him. This is my book, and it was a labor of love during COVID and a total knee replacement operation. But before I begin, Melissa May, I have a gift for you. It's a going away gift. This young lady I met, Aaron's going to bring it to you, and Aaron's going to help me with this presentation. She is an amazing person. I served on the San Juan Soil and Water District Conservation for a couple of years. And I was just amazed. Aaron, come on up here. Please. Yeah. And she's leaving us, and I'm sad about that. But Colorado is lucky. They're going to be getting her tremendous efforts and intelligence. And she's introduced me to Alyssa, and she started that group. And Alyssa, I have a project for you. So I'll be getting with you. I also am concerned about water rights, and I was glad to see this book out there. 15 times my little West Hammond, it used to be, now it's Lee Hammond, group turned down offers to buy water rights 15 times. And I thought, by golly, that's my next project. You know, who are those people? Do they still have access to those? I'm going to track them down. I want to tell you just real quickly, this was, as I said, a labor of love because during COVID, when my daughters made me stay home, wouldn't let me go anywhere, I didn't know what to do with myself, but I started studying. And in those minutes, 52 years of them, my husband talked to me because he was in the minutes. And it was just a wonderful experience. Whoops, I forgot my glasses. Let me get them.
I didn't forget mine. They're in my pocket.
I want to start out letting you know how we got involved in this. My husband worked for El Paso Natural Gas Company. He worked shift work, which meant he thought he had a lot of days because on evenings and graveyards, he'd stay awake and start businesses. And we got into a lot of things. And because he did, I did. We ranched, and then we moved out on the West Hammond, and we have about 100 acres, and I grow alfalfa hay. The San Juan River was not contaminated. And guess what happened? Farmers, and we sold out of hay for 2 years in a row because people wanted hay that had no possibility of having had contamination from the gold mine. One thing that I learned is you have to put all your energy into something. And my husband was that kind of guy. And I got sort of tagged along. I learned how to operate all the farm equipment except for the baler. I mean, for the one that picks up the bales. We helped each other. When we moved out on the West Hammond, there was a dirt road and no water. So we hauled water. We had 3 little children, 5, 7, and 9. We gave them baths in a little tub, and Harold and I would take sponge baths, but we had a house out at Chaco Plant. So we'd go home, but it was 56 miles round trip. So one day I got really tired. I said, I'm just going to go take a shower at school. So I got my 3 little girls, and we went up there. I was in the shower room taking a shower, had my girls out there, and I heard these men talking. I thought, what's going on? So I hopped down, wrapped the towel around me, tried to get dressed real fast. And the little girl said, Mom, we told them you're in there, and they kept walking. Now, I hope they didn't see me, but I never did ask them. But the next day, they were at the front door grinning, you know. And I thought, I'll go around the back door and go in. And I went home. And I said, Harold, I'll help you on trying to get that drinking water. And so we did. 4 men. There was Earl Hickam. You'll recognize some of these names. Charlie Keller, Harold Clore, F.N. Cornett, and Mike Taft. We started meeting and meeting and meeting. We figured out we need money. So we wrote a grant. Now, I'm kind of a strong Democrat and I hang around with this Republican, but that's okay. And Governor King came to our house for an event we had there. And he got out of his truck, walked right over to the hay barn and started inspecting the hay. While he was there, Harold said, Governor, we've got a grant written. I'd sure appreciate your attention to it. Guess what happened? We got it. So we started this little system. There were 17 people that lived out on the West Hammond that wanted water, 17. Today, there's approximately 3,000. The amount of dollars they started out with and committed to was 12,000. Now it's over 3 million. We serve a lot of people. The value of my land from $474 an acre, if I have drinking water, is about 20 to 30,000 an acre, depending on how you use it. So we learned a lot along the way. There were ups and downs and confusion and arguments, but those men, those 5 men, served with no salary, just a love and the heart to serve their community. I want you to remember that. And that was about, I think my husband was on the board 20 years, maybe 16, but it was just an amazing thing to watch. Now, along the way, we ran into problems. I got to watch because I'm going to turn it over to my friend here. One of those problems was political when Earl Hickam and San Juan County had a convention in Albuquerque to start the New Mexico Rural Waters Association. The politicians wanted the money. The people wanted the service. And guess who won? The people. They called a convention at the same time that Earl had called one. But Earl and Charlie Keller were instrumental in pushing the association through, and the other ones failed. So it takes people, it takes committed people. Then we come on down to Animas La Plata. Well, Paul, I heard you mention the word as I was walking by, return flow study. Ho, ho, ho. What was it, 1996, I think it's when that started, 97. Still not done. Thank God they're using Aaron's dad's, right, for that study? Because then if we get that done, everybody else can get theirs done. We, West Hammond, we know we could have more water. because of the return flow study. There's this big old political argument going on. And we think we could have 72% return flow. They've only allowed us 52%. So it's worth studying. Another thing that happened is when we began to have, I don't know how to say this nicely, a lot of problems with Bloomfield. And I live in Bloomfield, so it's okay. I'm sort of in Bloomfield. They just were raising the rates and creating, once we got the water line in, problems. So Lee Hammond and West Hammond started talking. And my husband made the motion, let's build our own water treatment plant. And we did. 50%, nothing in writing, unfortunately. It's just a gentleman's agreement. Now, at that point, I'm going to turn it over because I ran for the board when I discovered I could not get any drinking water to think for the future of my daughters that may have to subdivide when I die and we aren't farming anymore. We're still farming. And they said, no, there's no water. And I said, I didn't say it, but I thought it, what the hell? So I started studying it. I got with Melissa, I got with the state engineers, I got with this guy because the local manager operator would not talk to me, meet with me, or return a call. I ran for the board. The night or the day of the board meeting, her mother and she were campaigning against me. That made me really, really mad. But I'm also a very good Christian. So I prayed to God and God said, forgive her. Because that night, another board member resigned. They had 3 positions to the 2. I got appointed. And God said, forgive her. You're on the board. Let it be her problem. And I did. But the 2 things we wanted more people than one to be in the financial understanding. And we wanted to know exactly where the meters were. She wouldn't do. A few months later, she left on a Monday. And he and I were sitting at the computer trying to figure out how to get into the financial records. Guess what was there? A sticky note. He tried it and it worked. So we then merged. And that's where I introduced my good friend, good employee, and amazing guy, Aaron Lee. This is Aaron, but it must be something.
Just lay it there. It's all right. So you guys understand what voluntold means when you're an employee and one of your board members says, hey, I signed up to speak at this event and you're going to help me. So she kind of talked about the West Hammond side of the water system. I'm going to talk for just a minute about the Lee Acre side of the water system. In 1967, Lee Acres formed a water users association on the north side of the river. Design and construction began in 1969 and was completed in 1970. So it went pretty fast. So there wasn't a whole lot of people on that system. I think it was about 35, and that included some people around Tommy Bolak's place and some people over on the outskirts of Bloomfield along US 64. At the time we purchased water from both of those cities. We didn't produce any of our own water. Over the years, the well water got worse and worse because they built more houses, and you guys have been talking about some of the issues with that. In 1998, as Carol said, the 2 systems voted to work together to build a water treatment plant. That was built and went into production in 99. It produces a maximum of 1.5 million gallons per day and feeds all of the population between Farmington and Bloomfield along the US 64 corridor, and south across the bridge at the casino, and then all the way out to 550 and down Sullivan Road, and back to the river. So all of those people get water from our water system. If you live out there, you pay your water bill to my office.
Thank you.
So as she said, there were, West Hammond had some issues not too long ago. And in 2021, the beginning of the year, we voted to merge our two water systems together. Something I had been working on for probably 4 or 5 years. For the simple fact we had this water treatment plant. We worked well together before. We had one of their managers had a heart attack, Nick Ashcroft, and died in his sleep, luckily. And so they didn't have a water operator certified to operate the treatment plant. So we decided to merge at that point. We now serve a population of about 8,700 people, roughly the same number that the city of Bloomfield or the city of Aztec serves. We have 7 storage tanks, roughly probably 140 miles of pipeline. I know it's only like 30 something miles from one end to the other, but there's a lot of pipes in there. And taking care and maintaining those is what my employees do every day. I used to do it a little bit, but I'm getting a little round now from sitting at a chair too much. We work very hard to provide the best water we can, and we meet all of the national, federal, and state standards. Plus, we beat most of those significantly on a daily basis. We do all the water sampling that we're supposed to. In fact, my guys took samples yesterday for DOCs and for trihalomethanes and haloacidic acids. We're going to be doing lead and copper samples next month. The future for Lee Hammond, I don't know. It's changed a lot in the last 30 or 50 years, and it's going to change some more in the next. Where it goes, I don't know, but I will stand for questions if anybody has any. Did you want to add anything?
I do, before we do the questions, if I may.
Okay.
I want to invite you somewhere tonight, and it's free. There's a cowboy singer, and I'm sorry, I can't remember his name. Do you remember, Melissa? Anyway, he was a cowboy, and then he turned into a singer, and he's performing at the Farmington Convention Center downtown at 6 o'clock. The San Juan Historical Society is putting it on. I also want to tell you that I went with Aaron to the Colorado River Water Users Association last year. We have problems, big time for the future. Even though it snowed real well last year, I learned there the ground was so porous, it didn't get to the river like it should. Pay attention, because I think it's going to get worse. But there are people like you and like Aaron. We'll figure it out. If we have to, we'll bring over that runoff from the Mississippi, you know. And the third thing is Friday, we have a nappy tour. And those of you that have signed up for that, I want to give you the address of where we'll meet. It's on the corner of San Juan Boulevard and Scott Avenue. There's a bank right there. And right behind that, there's a dirt parking lot. And my daughter, who's a superintendent of Bloomfield, is sending their activity bus to take us out. And I want to thank Mark. He's been wonderful to help coordinate all of that. Okay, now questions to Aaron, probably.
No questions.
You're hungry.
That's even better.
Carol, I just wanted to let you know, somebody on Zoom wanted to get the title of your book and where it could be found.
Okay, the San Juan Historical Society has a copy.
Talking to Mike.
Yeah, I guess so. The San Juan Historical Society in Aztec has a copy, and Artifacts Downtown, they have copies. It's $10. It's a labor of love, not a novel.
What it's called.
The name of it is Water, Water Everywhere, and Not a Drop to Drink. San Juan, Animas, and we couldn't get water. We hauled it physically. That is hard work.
Is that a question?
Suggestion.
Sure.
Years ago, they took pictures and they were stained. They occurred to you. If you wanted to take it here, it was on Harper Hill. San Juan County had it. On Harper Hill, Jody Boston was the state of the conservation. Yes. Hired two of those kids, paid them $1 piece. Picture. Beautiful valley.
Sure.
Alfalfa and apples. Today, we have houses.
We have houses.
Don't put houses upslope. We can't eat houses.
So that is true. So what he said is that we're turning our farmland into residential dwellings. And we're doing that at a very fast pace. It's because the land's worth more to put people on than it is to grow crops on.
And it's hard work to farm, guaranteed.
So our children don't want to farm anymore. They want a job where they sit at a desk like me. He was saying that we should move the houses up slope. The problem is most of the land that is not under irrigation, at least on my water system, is either tribal or it's federal. Some of it is state land, but there's almost no private property that doesn't have houses on it already or farms on my water system. Now, there's some others that there is some private property on. There's also ways to do some trades and stuff like that. I agree. And if we can find a way to turn some of that and make it that way, it would create a little more work for me because then I'll have to figure out how to put tanks higher. But we can do that. They build elevated tanks in other places. That's right. So good luck with that. Anybody else?
I just thought of something that I thought amazing. Nevada is paying people not to have lawns, like $3.75 a foot, I think, square foot. Yeah. And they're going to give them, I understood, until May. And if they hadn't done that, they'll turn off their water. It's getting serious. Okay.
That's it. One more question from the chat. I think somebody, was there another book on water rights that you mentioned, Carol? Somebody wanted the title of that.
It's called 100 Years of Water Wars in New Mexico. And it looks like it's put out by the New Mexico Water Resources Research Institute. I guess they're selling it here.
Yeah.
Is that?
Yes. And if you'd like, you can purchase a copy at the check-in desk.
Perfect. Thank you all. Oh, we have one more.
All right, Carol, you were talking about water rights and the fact that your company didn't want to buy water rights. What do you think is the most important thing that we should all know about water rights, especially in New Mexico?
In the 40-year study that the West Hammond did, we are going to grow within, I think it was the next 40 years from when it started, 62%. We'll need 62% more water to drink. There's not going to be that water. However, there is, I learned, through the Animas La Plata, but you have to do it through an association that's a member of that, which we are. But as an individual, you can't. Thank you. Very important. Thank you.
I'm gonna turn it over to the other Aaron.
Yes, thank you both of you for your presentation. So right now, lunch is ready to be served. I'll direct everyone, you can go through the doors over on this side, run through the buffet line and then come back in. And yes, at around 12:30, we'll be hearing our presentation from Aaron Chavez. Thank you, everyone, and enjoy your lunch. Okay, everyone. I hope you've been enjoying our lunch. Right now, it's my honor to introduce our luncheon keynote speaker. Aaron Chavez obtained his bachelor's degree from the University of New Mexico in 2000 and has worked for the San Juan Water Commission since 2001. Currently, he serves as the executive director of the San Juan Water Commission and was also recently appointed president of the Colorado River Water Users Association. Aaron, it's an honor to have you here, and there you go.
Thank you, guys. One last thing, I've been appointed to the Interstate Streams Commission as a commissioner. So I wear that hat also just recently from the governor's office, got that appointment. Like Mark mentioned, my name is Aaron Chavez and I've been the executive director for the Water Commission for about 7 years. I know Melissa and Paul and a few of you out there, Carol, that we work with locally, and it's good to see your guys' faces. So this presentation might be a rerun for you guys, but hopefully I enlighten someone about the Water Commission and the drought contingency plans of the Colorado River. I always put this slide up, discussing water rights at Western Pastime. It's always a fight, no matter what we do in the basin, in the state, in the region, in the nation. And water is no different than anything else. There's always hurdles and obstacles we got to overcome. And I like just to show that you know, this job is a tough job, but we have to do it. Water supply, the Animas River Basin. I don't know, I didn't come this morning. I'm sure you guys seen this hydrograph today, or maybe not, but the Animas River gauges showing that we're close to normal snowpack, but it came off early and the supply isn't there like we expect. The river should be roughly running 3,000 CFS today, and it's roughly 900. So we're doing very low. That's in the Animas River Basin. San Juan River Basin, we're just as the blue line, as you can see. Hope no one's colorblind, but the blue line is what happened this year, 2022, and the purple line just the median. So we're close to average, but like that hydrograph shows that the water came off faster than normal or earlier than normal, and our runoff isn't as great as we thought it would be. And a lot of that's due to soil moisture. And that's this next slide, the soil moisture in the Colorado River Basin. The slide on the left was soil moisture the fall 2020. Soil moisture fall 2021, showing the moisture to be worse in the San Juan Basin area than the previous years. So that's a lot of the issue is due to no monsoon. We do get snow, but no monsoon. So that's the issue. So the way I see it is the soil is like a sponge. And if you don't, the sponge soaks all the water off, even though we have a near average water supply, the sponge soaks it off before it runs off. So that's why we're having such low flows in the river. I'd like to just show this reservoir status in the upper Colorado River Basin. Navajo is 58% full, or 58. Blue Mesa, Flaming Gorge, Lake Powell, they're all pretty grim. Flaming Gorge is looking pretty good, but Lake Powell is 26% full. So in the upper basin, upper Colorado Basin, our reservoirs aren't looking that great. But in the San Juan Basin, McPhee did okay this year. Jackson did really well. Lemon and Vallecito did okay. But the one that I kind of like to brag about is the Lake Nighthorse, which is 100% full. So the reason I talk about Lake Nighthorse, that's the Animas La Plata project. But how it began, local pioneers noticed there was great land in the La Plata Valley, but they noticed there was no water in the La Plata Valley. So in 1908, members of the Taylor family traveled to Washington, D.C. to seek funding to improve water to move water from the Animas River to the La Plata River. And the Taylor family received $8,000 for the study in how to move the water. That's how the inception of the Animas La Plata project began. So I always think about 1908, $8,000, that's probably a pretty good chunk of money. And I always show these pictures. The top one, the city of Durango. You can see that's Lake Nighthorse, Animas La Plata project. And in respect to the city of Durango, both images. But before we get into the Animas La Plata project, just wanted to cover what the San Juan Water Commission is, and we're more than just the Animas La Plata project. We're involved in many areas, invasive species, aquatic, woody, regional and state water planning, the recovery program for the endangered fish, water quality, and that's through the Triennial Review, Gold King Mine, and San Juan Watershed Group who participate. We also address adjudication issues in the San Juan River Basin, and we look at water development, conservation, and infrastructure projects in the county. So these are just kind of the purposes and the goals of the Water Commission. It was formed in 1986. Primary goal was ALP. But the one thing I want to stress is, we want to protect and utilize future and existing water rights and water resources of its member entities, which are allocated to the commission for their needs as a group. And the big thing I want to stress is we want to ensure every citizen in San Juan County has a reliable supply. That's our mission and our goal. Like I said before, the San Juan Water Commission was formed in '86 through a joint powers agreement. I'm the executive director. The parties that belong to the Water Commission are the City of Aztec, City of Bloomfield, City of Farmington, San Juan County, and the San Juan Rural Water Users Association. So the San Juan Rural Water Users Association includes Lee Hammond Water, Navajo Dam, and the list goes on and on. North Star, Florida Vista. There's 11 members total on the commission. So I did list them. I should have looked at that before. Sorry. Blanco, Florida Vista, Lower Valley, and so on and so forth. So we do have a water resources department, a GIS, IT, web, administrative services, and some of the other projects and programs we talked about, like the endangered fish species, regional state water planning. We want to look into top water banking, leasing some of our water rights for economic development, water conservation, infrastructure projects, so on and so forth. This is just a member entity map, the service areas for the ALP water. You can see lime green is City of Farmington, and Lee Hammond, that needs to be updated, but that's the blue and the other green, and just the lay of the land in the county. That's who we provide water to, and their service areas for the San Juan Water Commission. There's a image of the Animas La Plata project that I've been talking about. It was authorized in 1968. It included irrigation for the La Plata at the dry side, along with municipal industrial supplies. Back in 2000, it was, they call it the Animas La Plata Light, and it only included municipal industrial supplies. So a lot of all the irrigation was taken away, and it's solely, so you can see the both, compare the two, the yellow and the green and the brown was the original project, and this is a new project, and you can only see the reservoir. I don't know if this pointer works. Probably not. Includes a reservoir at Lake Night Horse and a component in New Mexico that serves the Navajo Nation, a pipeline from Farmington to Shiprock. Some of the pictures of the Durango pump plant. So if you look at the top left picture, it was the excavation of the foundation of the pump plant, and then the bottom right is the completed pump plant. And I always thought it looked like a train, like Durango, the Durango train. So maybe it does, maybe it doesn't, but that's the way I see it. And if you're familiar with Durango, it's across from Santa Rita Park. So that's where the pump plant goes. And there's another image of it from the Santa Rita Park. And those are the diversion structure, and it pumps it up the ridge over into the Ridges Basin. Pictures of the pump plant, some of the pumps, the engine, 1,000 horsepower electric engines, and we have the capacity to run 287 cubic feet per second through a 72-inch conduit. So this is during the first fill, that's what was coming out of the pump station. Good stream of water. There's another aerial photography of the reservoir, or the dam structure before the reservoir was filled. So you get an idea of the magnitude of the structure. Just wanted to give some stats. I don't have these memorized, so forgive me for not knowing everything, but the crest length is 1,640 feet. We can release a capacity of 110 to 200 cubic feet per second, about 123,000 acre feet of storage. And the Durango pumping plant has a maximum dynamic lift of 550 feet. So just some of the stats on the project. So in 2002 was kind of the wake-up call that we're in a drought, and possibly a mega drought. No one would assume that we would have been in 20 years later in worse shape than we were in 2002. But this was a image of the San Juan and Animas confluence, and you can see the Animas is totally dry, and it's been dry numerous years since then. And this was we did make a release through the Animas La Plata project last year, a couple years ago, actually in 2001, sorry. Animas La Plata, we did a release to test the system on March 15th, 2001 at 8 a.m. in the morning. And this picture is near and dear to us because Jim Dunlap, who was founding father of the Water Commission, he hit the button. Unfortunately, Jim passed away last month, so we lost somebody that had great knowledge and great attitude and always wanted to make things work. So he had the honor to hit the button. So the Water Commission made a request for a 410 acre feet for 5 days. The initial release was for 44 CFS for 3 days. Then we reduced it down to 38 CFS for 2 days. And the breakdown with the participants were North Star, City of Aztec, and Southside. Flora Vista, City of Farmington took a percentage of that water, roughly 25 CFS, for a total of 248 CFS to top off their reservoir. And Lower Valley, we were really pleased with the results. We we gained information as far as losses, time of travel. So we got great information and we're able to track the release from the gauges that we had in place. And this is just an image of the release from the outlet works through Basin Creek. And this graph shows kind of where it was in the stages of the release. And like I said, we calculated travel time and other information. Mark, I don't know if we're going to provide this information on your website. I don't want to go over all the little details, but some of the information is from Bridges Basin to the Animas River. It was 4.3 miles and it took about 8 hours travel time. So we got great information. And then this was Animas River at Penny Lane near Florida Vista. So as you can tell, on March 16th, Penny Lane, the Animas was dropping, and then the water got there and kept it pretty much level. If we didn't have the release, the dotted line would have been the projected drop because Farmington turned on their pumps. And the pink with a pink dot line would have been the flow if Farmington didn't turn on their pump. So we had a good comparison. I'm not going to go over the results. Like I said, we'll post those on the website if we post the presentations, or if anyone wants, I have my cards and you can share this presentation with you guys. So the big issues now in the Colorado River Basin is the drought contingency plan, or the DROA, the drought response operation agreement. I like to just, we show these teacup diagrams and how Powell was very low, and then the lower basin is even worse. Lake Mead is 29% full. Some of the larger reservoirs in our basin are extremely low. So why are we so concerned? So the drought contingency plan and the drought response operations agreement allow it's a mechanism to allow to protect the elevations in Lake Powell and Lake Mead. Lake Powell is a concern for many, is because it's a hydropower plant. It provides WAPA power to rural areas in New Mexico, and actually it provides power to the Animas La Plata project to pump the water into the reservoir. So we're really concerned with where that is. WAPA power is obviously cheaper. So in the end, if we don't have WAPA power, cost to pump the water into Night Horse maybe double or triple. Rural entities in New Mexico can, people live in a co-op, they may have to pay more for their power. So it's a balancing act where we want to preserve our water, but the power issue is also a big glaring elephant in the room. So what is the drought contingency plan? It's planning for drought to reduce risks, to take a proactive approach, control our own destiny. Some of the drought contingency plan or DROA stuff is weather modifications, drought response operations. Like I said, we want to reduce the risk of Lake Powell reaching a critical level of 3490. Target elevation is 3525 to minimize the risk of reservoir declining. At this time, a couple months ago, the Lake Powell did drop below the desired level of 3525 for a while until runoff came in and it raised. So like I'm jumping my slide, sorry. Lake Powell dropped below the target elevation for the first time ever. The current water elevation has never been seen since the first fill. The reservoir pool needs to produce hydroelectric power. water supplies for millions of people in the West, and it is shrinking. So what does that mean for us? I mentioned power costs, water supplies, and where does Navajo Reservoir fit into this? So last year, Navajo Reservoir was considered as part of the CRISP units, part of the Colorado Storage Project Act. And Navajo was considered a resources to make a release to help prop up the elevation in Powell. Fortunately or unfortunately, the hydrology isn't there at Navajo. It's low like everywhere else. So they did not make a release out of Navajo to prop up the levels of Lake Powell. So they do, the Bureau operates Navajo, Flaming Gorge, and the Aspinall units in Glen Canyon. So the Bureau always is doing a 24-month study every month. And if hydrology changes, they may tap into the other reservoirs. So another New Mexican, Tanya Trujillo, who's the Assistant Secretary for Water and Science in the Department of Interior, asked that the lower basin only take 7 million acre feet instead of 7.4 million acre feet. And then the Bureau will release approximately 500,000 acre feet from Flaming Gorge for the water year 2022. So in the end, we're reducing the demand on Lake Powell by roughly 1 million acre feet. But who knows what's going to happen in the future if we continue down this mega drought. These actions may not be enough. One last thing I wanted to talk to you about is Mark mentioned that I was a president of the Colorado River Water Users Association. It's a great organization. We have a December meeting, annual meeting in Las Vegas, December 14th through the 16th, and I invite everyone to go and attend to learn about the Colorado River Basin and all the issues that are facing not only New Mexico, but the upper basin and lower basin. And this is what I always dream at night is snow on trees and snow to make things better. And I want to comment on Paul. This is at Lake Farmington, right above his water supply. So that's when I took that picture was at Lake Farmington. So I just wanted to give props to Paul and his organization. So that's all I have. Do you guys have any questions? If I confused you, I'm sorry, but if not, it looks grim. Yes.
What is the Long Hollow Reservoir?
That is a reservoir on the La Plata River that takes return flow from the ditches in the upper reaches of the basin. And that reservoir is to ensure compact deliveries for the La Plata River, the La Plata Compact. So they make small releases out of Long Hollow to ensure the water meets the state line for compact deliveries.
So what a federal reservoir was it? State?
It's state. It's a local Colorado reservoir, the state of Colorado.
My question is, so you mentioned this plan to reduce the demand on Lake Powell partially by reducing the amount that is required to flow downstream. And I'm wondering what repercussions do you see for this on, for instance, Lake Mead, which is downstream and also rapidly declining?
So that falls on the lower basin states, so California, Nevada, and Arizona. So they've come up, they're part of their drought contingency plan is called the 500 plus plan. So they're willing to take shortages in the basin to ensure that the water, so the demands are met. So Arizona has the most junior water right in the system in the lower basin. So they're the first ones that will be shorted. And so they're prepared to take that shortage. And then Nevada is actually a smaller user. They have 300,000 acre feet in the system. So they aren't as affected as much as, say, Arizona, and California. So California has the most senior water rights and the most water rights. So they're the ones that will be affected the most if there is additional shortages. So at this point in time, the shortages will be Arizona's burden to bear.
That meeting you mentioned would be virtual?
Not sure. We try to do both, but this last year we had it in person in December. So it's just kind of hard to have presenters and everything virtual. So I would say it would not be virtual, but it would be in person in Vegas. Yeah.
Water Users Association, just curious, do you guys have like the data?
The Colorado River Water Users, yeah, the membership is called 10 Tribes Partnership. And we have the 10 tribes represented in the basin, upper and lower basin tribes. So the members that represent New Mexico are Darrell V. Hill from the Hickory Apache. You had a question?
I was just curious about how Lake Night Horse factors into water supply and demand for us around Farmington and San Juan County.
So out of the 120,000 acre feet of storage or project water, the San Juan Water Commission has 20,800 acre feet for municipal industrial supplies. So that member list that I mentioned, the 3 cities in the rural in the county, they all have a percentage of that water. So when times of drought, say the Animas goes dry again, we may make a release out of Night Horse so our members can grab the water and ensure that the water is available to their customers.
Is there a pipeline in progress to get water direct from the lake down here? Or is that?
The Water Commission, we're doing a strategic plan and that will be in it. We did some initial engineering and cost estimates and it's very expensive, but that is still on the table that we're investigating and we're always looking for out of the box ideas to ensure we have a reliable water supply and that we're resilient. Because if you go anywhere in New Mexico, Middle Rio Grande, you have your aquifers, you have your San Juan Chama project, you have the Rio Grande. We solely only have our surface waters and we got to make sure we protect them and we make sure that we can become resilient, meaning pipelines, regional storage facilities. Other things are, some of the other concepts around the state are produced water. What do you do with that? Water reuse, aquifer storage and recovery. I mean, there's a lot of options out there, but we need to investigate those and we need to move forward. And my current board is really proactive and they want to ensure that we are resilient for the future. Carol.
When I went to the Colorado River Water Users Conference, it was very good. I heard about Los Angeles County. They're in the process of reusing the water. So you always have to say water. Is that what I do?
Well, they're becoming creative. So the first thing, they call it purple pipe, and they get water from your effluent and they maybe water your parks or golf courses initially. And then if you need more water, they start treating it and putting it in the potable water system. It's a stigma that people hate to think about. I wouldn't want to drink my own effluent, but they say that it's cleaner than what they get it when they put it back in the system. But there is, like in New Mexico, we have a consumptive water use where we consume and we can use it till eternity. So they're just maximizing that concept.
That's a little bit of hope.
And creative ideas and hope, I guess, or I don't know. I would probably, if I was in LA, I'd probably invest more in the desalinization more than purple pipe issues. But there's costs and environmental factors that are always in the mix. Any other questions? Yes.
I can't remember if it was Lake Powell or Lake Mead, took 18 years to fill. And it's down now 2/3. That would be, that would be 12 years to refill it. Is that going to be possible if this drought ends?
You know, I don't know, because took, say, 12 years to fill, or even longer. 18 years to fill. That was when there was less demand in the system, so less people. And the hydrology was way better. It was a wet period of time. So even if we started getting normal years, I think it could take longer than that.
Thank you.
And one last thing about Lake Mead, we were in Vegas doing it's part of the Colorado River Water Users Association, and there was a local article, and they found a barrel with a body in it in Vegas. So that's where the levels of the lake are at. They're a lot lower than what anybody would ever have thought. They said it was around the time they dated it back to the 80s because of his or the person's shoes and attire. They could kind of reference that he was dumped back in the 80s. So I'm not sure, but we're in a dire, grim situation, and being part of this puzzle is tough, but I hope to figure it out. And Rolf Peterson Schmidt is doing a great job. So is Esteban Lopez, that represents New Mexico on the Upper Colorado River Commission. So we are in good hands, but ultimately we need snow and rain. Anything else? Otherwise, thank you. Appreciate your guys' time, and I hope I didn't bore you, and I hope you have the great afternoon. Thanks, Mark.
All right, thank you so much, Aaron. We have about a little less than a half an hour before we'll be beginning the afternoon portion of today's program. So take a chance to clear your plates, stretch your legs, and get any refreshments. And we'll start again back at 1:30. Okay, everyone, if you could, everyone could start moving into their seats. We'll get started with the afternoon portion of our program. And with that, I'm really delighted to be able to introduce Sarah Goldstein. Sarah Goldstein moved to New Mexico in August 2021 and took a job with the Office of the State Engineer. In March 2022, Sarah took on the role of water planner with the New Mexico Interstate Stream Commission. Sarah is originally from Colorado and obtained her bachelor's and master's in civil and environmental engineering from the University of Colorado Boulder. Before moving to New Mexico, Sarah worked as a consulting engineer in Denver, Colorado. I just want to say as well, it's been a pleasure to work with her and her team at the Water Planning Office of the Interstate Stream Commission, and helping to contribute to the 50-year water plan. So everybody, welcome Sarah Goldstein.
Thanks for that introduction. Is this a good? Okay. Hi, everyone. My name is Sarah Goldstein. I am the state water planner. I started as a state water planner back in March of this year. So basically the last time it snowed or got any precipitation. So today I'm going to go over the 50-year water plan, which is going to be a review of the contents, and then kind of talk about where we are at in the process and then our next steps, and then hopefully leave enough time for questions. So what is the state water plan? So I want to start with what it's not. It is not the state water plan. It is not a regional water plan. It's not a technical report. It's also not all doom and gloom, though there is quite a lot of that. And it's not the solution to all of our state water problems. And most importantly, it's not just going to sit on a shelf. What it is a governor's initiative that Governor Michelle Lujan Grisham started in her 2018 campaign. Its aim is to help New Mexico plan for climate change and the impacts of climate change on our water supply. It's aimed at our decision makers and the general audience. So it has a very kind of bottom line upfront report. And it's only going to be like 35 pages. So hopefully everyone can have a chance to read it. So what's in the 50-year water plan? So we have our classic introductory aspects, our introduction, executive letters, introduction, and then we have 3 main sections and then our recommendations, which I'll go over next. We also have a bunch of supporting material, including material from WRI and their report that we commissioned for this report, in addition to other aspects. So we'll kind of just run through what's in the plan next. So if you're new to New Mexico or you're very, seasoned in New Mexico water planning in New Mexico and water in New Mexico is a very fragmented endeavor, really. Lots of different state agencies, lots of different federal agencies, lots of local agencies. And therefore, it's really important when the ISC set out to do this plan that we developed partnerships with lots of different people. If we're just one agency planning on our own, it's really easy to ignore us. If we are lots of agencies planning all together, hopefully we'll have a better chance at having an impact. So people I'd like to highlight are on this slide. So we have the New Mexico Bureau of Geology and Mineral Resources. They commissioned the Leap Ahead report, which looks at the impacts of climate change on the state of New Mexico's water resources for the next 50 years. And was made up of volunteer research experts. We have the New Mexico Indian Affairs Department, which we worked with to develop the Tribal Water Working Group to make sure that our tribes, pueblos, and nations had a specific and very important seat at the table and that their voices were heard and elevated in this report. We worked with numerous other state agencies, including the Environment Department, MNRD, Game and Fish, Homeland Security, and Department of Health, lots of other people. And additionally, we also focused on engaging with stakeholders across the state through the New Mexico Water Dialogue, through Water Resources Institute. And through all this process, we also had support from the U.S. Army Corps of Engineers through their planning effort, their CAP program, which allows planning resources to be held for the state. So they've been really instrumental as well. So that's our first section. Second section is the Leap Ahead analysis. So this was commissioned by the Interstate Stream Commission, but as a research report done by the New Mexico Bureau of Geology and Mineral Resources. And so, as we can see on the slide here, the main takeaway is that we are getting hotter, but not necessarily more wet. So you can see kind of that average bar is going up over time, and this only goes to the present, but our precipitation has been relatively stable. So this is going to change everything about New Mexico and New Mexico's water resources, and ultimately will impact all aspects of New Mexico society, how we live, how we work, where we farm, where we don't farm. So given this general trend ends up with New Mexico having increasing aridity. So you can see here, map A shows our current aridity, where areas that are red essentially have more evaporation versus like the areas in blue. And we can see through map B, which is the projections, there's a lot more red and yellow and a lot less blue, which essentially means it's kind of, think of it like a drying machine. Like we're just being put into a drying machine, no more water, but a lot more heat. So we're essentially drying out a lot more. So that's not super great news, but I guess some of the good news is that we're in it together with a lot of other people. So, so in this map, this is a water stress map of the United States. And what's important to note is that any area with color is essentially expected to change over the next 50 years. Areas with a more brown color are expected to get drier, while areas that are bluer are expected to get wetter. Ultimately, though, changes in our natural environment will impact everyone across the United States, except for those like few areas that are white, which really is nowhere. So knowing all this, we've made a slide that kind of summarizes the main impacts that we have due to climate change. And the one I'd like to focus on is that top one. The average temperature rise for New Mexico is going to be 5 to 7 degrees Fahrenheit on average. So that means, through the entire year, both from like the winter to the summer, from here in Farmington all the way down to Carlsbad. So there's going to be more extremes throughout the state, and it's going to manifest differently. But then the other thing to note is that every single one of those bullets are essentially a cascading impact of that temperature increase. So one that I'd like to point out is increasing catastrophic forest fire frequency resulting from heat and dryness. We're already seeing that happening, as seen by the Calf Creek and Hermit's Peak fires that are currently still burning in the Pecos wilderness. So pretty bleak, does build on a lot of what we've heard this morning, but what can we do about it? So the second step of the 50-year water planning process, the Interstate Stream Commission commissioned a resilience assessment report, which worked on identifying how can we increase resilience throughout our communities statewide. So what was identified in that report was the 5 aspects of resilience: water diversity, water availability, infrastructure capacity, watershed health, and demand management. Now, you don't have to have all 5 of these to be resilient. You could have a combination of any of these, but the most important thing is trying to increase your ability to either diversify your supply, increase your capacity, or protect your watershed health in order to be more resilient for the changes that are going to come. So with all this kind of like legwork behind us, we use those as the foundation to develop our recommendations. And what's really important to note is that these recommendations, we've grouped them into 3 main categories: stewardship, sustainability, and equity. Now, a lot of these aspects could fall into many of these other categories. So I wanted to kind of give a quick explanation about what we mean when we talk about stewardship, sustainability, and equity. So stewardship is defined as the preservation, restoration, and monitoring of the ecosystem. So I like to think of it as your watershed. We're going to start up in the top of the watershed, move down through lakes, rivers, and reservoirs, and eventually reach our groundwater. Sustainability refers to the human system that need adaptation to address these changing conditions. So under these, we have continue to innovate in water conservation, modernize administrative management practices for water, and modernize water infrastructure. And our final aspect of our recommendations is equity. And equity is referring to the guiding principle from which all of our underlying work should be essentially completed. So within this is specifically focusing on engaging with our tribes, pueblos, and nations throughout water management and learning from their traditions. Protecting our acequia culture, which is really key to the culture of New Mexico. Optimizing alternative water sources, and then continued research and planning. So to dive a little bit deeper into each of these, as stated before, water in New Mexico is a very diverse state and who has responsibility. So we've identified different state agencies that will hopefully be able to take on the lead with regards to some of these aspects. So improve upland watershed health. The main, as seen by the Environment Department's presentation this morning, they have a big program that's working on improving restoration of rivers. So that would fall solidly in the improved health of rivers, lakes, and reservoirs. And what you can see, we've identified the Environment Department as the lead agency. Improve upland watershed health falls within the energy, mineral, and natural resources department. They have the state forester within that department. And the protect groundwater health, again, falls under the Environment Department with their groundwater bureau. Our sustainability recommendations are really focused on the Office of the State Engineer, which is how a lot of people interact with the quantity aspect of their water. So we want to continue to lead in water conservation. I know Vegas was mentioned about ripping up their lawns as a water conservation aspect out there in Las Vegas, Nevada. Turns out Santa Fe has also a very, very good water conservation project, and they have reduced their water, I think, per gallon to like 90 gallons per gallon. I forget exactly what it's better than Vegas is what it is. That's always something like we want to point out. But so turning that kind of water efficiency throughout the cities is really important, but also working with our farmers and different agriculture to help figure out ways that we can turn that efficiency on farms into conservation for the whole state. We need to focus on modernizing administrative practices for water. As water becomes more contentious, more people are going to be wanting to figure out their water rights. And if anyone has had to deal with the Office of the State Engineer, they have a lot of outdated technology. So really bolstering their ability to be more flexible in their administration will go a long way in helping us solve our problems. And finally, modernize water infrastructure task force. State Engineer Mike Hammond has brought together a group of high-level individuals that are going to work on coming up with their own specific recommendations for water infrastructure throughout our state. This is specifically going to be focused on areas of technical administrative capacity and hopefully getting the funds that we're getting from the bipartisan infrastructure bill equitably distributed throughout the state in different projects. Our final area of recommendations is equity. So we are intending to increase engagement with tribes, public stations, and water management. This will be done by continuing our engagement with the Tribal Water Working Group, which is a group that we commissioned for the 50-year water plan, but has been a really successful way of making sure this group of people has a seat at the table and that their voices are heard. Protect a Sakiya culture by investing in water, fire resilience, and focusing on how to make sure that we can protect that culture while also focusing on adaptation. Evaluate water resources. So every time I think anyone gives one of these presentations, someone says, what if we piped in the Mississippi? So we're going to look into it, see how it is, and we intend to invest or commission a study on both the technical and economic impacts of various alternative water supplies, everywhere from produced water to brackish water to water reuse to piping in the Mississippi to training in the Mississippi. Lots of variety of options we're looking at there. And then finally, we are continuing research and planning. So one main goal of the planning department at ISC is to make planning an ongoing effort and not just something people hear about every 5 years when we're doing a state water plan. So that's going to be working on engaging more people, collaborating across all the various agencies. We are only a group of 2, so we can only do so much. And then learning from our sister states and working essentially as best we can. And hopefully this will also involve another kind of annual conference to help, continue to build the water community for New Mexico. So that was probably a lot quicker than I practiced, but here we are. Here we're at. So right now, our state agency partners have a copy of our 50-year water plan, and they are reviewing it currently. After that review is what's the word I'm looking for? Is incorporated into the draft. The task force led by State Engineer Mike Hammond will review along with tribal leadership. And then after that's all reviewed, we will then be releasing the plan for public comment at the end of July, along with the launch of a new website aimed at engaging people on multiple levels. We intend to also do a lot of presentations like this. Sorry, this is my first, so sorry everyone, you get the test run. But all of that to say, we will then incorporate public comment at the end of August and have our plan finalized in August or September. So that was a lot of information very quickly. So I'm here standing for questions.
Thank you so much for the presentation. I'm wondering, is there any alternative source that you are looking into right now? I know you made mention of study and report evaluation, but is there any particular one that as an organization is looking into right now or in the nearest future?
So the alternative water supply has a lot of interest. This is a kind of, we're trying to cast our net really wide. So we're not saying like, oh, it's going to be produced water. Oh, it's going to be brackish water, or, oh, it's going to be none of the options. So really trying to keep an open mind to both the technical and economic feasibility of all these different options. And so we're really, looking for the moon. I think I was told one of the previous state engineers said that we should lasso an iceberg and bring it back down to New Mexico. So maybe we'll look into that too. I don't know.
Hi, thank you for the presentation. I'm quite new for New Mexico, and I had a question. As you saw the resilience framework having the stewardship, equity, and one of the challenges for being defining resilience itself, that how you translate it into the practice, and how will you be monitoring the resilience that has been expected? As this is a plan, do you have any thoughts how the resilience will be monitored? Thank you.
It's a great question. I think that we're not quite to the point of monitoring the resilience of the plan because we're still taking the first steps of being aspirational about the plan. So hopefully this can serve as a building block where we can have a lot more, detailed projects that come out of this process eventually. But it's a process that, takes a really long time to build consensus around projects. And then I think the resilience and like evaluating resilience comes at that project level rather than like protect watershed level,
Hello, thank you for the presentation. I was just curious, I know this might be a lot for a team of two, as if your job wasn't hard enough as it is, but does the plan talk about, obviously it talks about climate change and these drivers that are contributing to the increased aridity of our landscape. For me, maybe trying to go away from the doom and gloom and being more solution oriented. We know what's contributed to a warming climate. So the part of the solution to our this 50-year water plan, right, is reducing greenhouse gas emissions and trying to address climate change. So so when I hear people say, well, we'll just, move the Mississippi River, is that really the easiest of the options? Would it not be easier just to reduce our greenhouse gas emissions, because training in water that's just contributing more greenhouse gas emissions? So I really don't see that as a realistic solution. So maybe more of so back to my question, does the plan,
address climate change? Yeah.
More front and center.
Front and center. The plan doesn't address like the root causes of climate change at its center. It's really looking at the state of the science and like looking forward into the future and the impacts. And, kind of regardless of what climate change and how we deal with decarbonizing our economy, we have a certain amount of warming baked in.
Right.
So this is really focusing not necessarily on the drivers of climate change, more on, we're going to probably get warmer. Is it going to be 5, 7, 9, only 2? Not really sure. Degrees Fahrenheit, that is. I think we're maybe already at 2, not exactly sure. But regardless, we have to plan for that now. So we're kind of taking climate change as kind of like the baseline fact, and the state of how we decarbonize and maybe slow climate change our course of action is not addressed by this plan.
Well, I'm hopeful that the realities will help, inform our decisions, because I think it's a difficult decision, but I'm just rambling.
No, I totally agree. I think that I hope that our water situation is it becomes very obvious very quickly.
Yeah, I guess what I was trying to say, there's no easy decision. And so maybe the realities of this difficult decision with water might make some other difficult decisions
Easier, yeah.
So,
Yeah. Is it easier to do these or is it
Right.
easier to just stop climate change? I don't know.
so I feel, just to wrap up my comment question, I feel like that's going away from the doom and gloom. I feel there's optimism there.
I agree. Yeah. Thank you.
One of the problems with warmer is that water evaporates more.
Yes, it's like that drier,
And so keeping the soil cooler
Mhm.
And protecting it from sun and wind is a way to reduce the need, reduce water use.
Yes.
And so there's already some solutions to that, is to use cover crops. Instead of leaving the land fallow and exposed to the sun and wind, to keep it covered.
So that's part of the solutions we'll be looking into, I think, back in, if I can go back a couple slides, within the stewardship aspect. So protect upland watershed. And then I think we have a focus on collaborating with farmers in the water conservation. So those will all be, so I should have mentioned this, these sub bullet points are the more specific recommendations. And each one of those we're hoping to flush out a little bit more as we continue this planning process throughout. Well, hopefully, here till forever, but who knows when.
Okay, thank you.
Any other questions?
Yes, one of our Zoom participants, Rachel, had a question. She asked, what do you see as specific opportunities for demand reduction in the sectors of agriculture and residential use?
Oh, that's a very difficult question. So I'm not exactly sure. I'm still fairly new to the job and I haven't had a lot of time to really look at the specific efficiencies and potential areas in which we can increase our efficiency throughout both the residential and agricultural areas. I would love to hear the Zoom commenters' ideas, because I have ideas, but I have no idea if they'll work. So I think a lot of research, and I think WRI, you guys are working on a lot of agricultural efficiency stuff as well. So I think, once again, I'm not exactly sure, but together we can hopefully figure it out.
I can contribute to that a little bit. Technical assistance is really huge for especially transitioning in the agricultural sector from very water intensive farming practices. That technical assistance to teach and to train and to supply farmers with the materials they need to get away from those more water intensive practices is very important. So having centers of education where we can spread the word about those is very important. And I guess somebody that works for cooperative extension, but that is going to be a big part of the support is through education and helping them find the resources to make those transitions.
That's a really good point. And I think just in general, educating the general population of New Mexico about where their water comes from, where the water is being used, and how you can make your part helpful is, I think, maybe like top of the list for the planning. Engage more people, and the engagement is engagement education, meeting people where they're at, providing them the resources they need.
And that does speak back into doing things like cover cropping and micro irrigation, irrigation planning in general.
Like a lot of people have been talking about, water and is, a through line through a lot of different aspects of our society and a lot of different state agencies and federal agencies. You know, the more collaboration, coordination we can get all together, the better off we'll hopefully be. Any other questions? So thank you for your time today. Really appreciate it.
Thank you so much, Sarah. Like I mentioned earlier this morning, we've had a slight change in our program. One of our original afternoon presenters was not able to make his presentation today. So we've moved the rest of our afternoon oral presentations up, which means that we'll get to our poster session here half an hour earlier, right around 3:30. And so moving on to our next presenter, Dr. Richard Rushworth, PhD, is an assistant research professor in the School of Informatics, Computing and Cyber Systems at Northern Arizona University. He is principal investigator on the Intelligence Advanced Research Projects activity funded Early Supply Chain Emergency Warning System, a novel effort to build an early warning system for critical lifeline supply chain disruptions. He is also co-PI on the NSF funded Transformation Network and lead research scientist on the NSF funded Fusion project. Dr. Richard Rushworth, the stage is yours.
Well, good afternoon, everybody. Thank you for that introduction. I just want to say first off, I'm here with two students and a volunteer from Northern Arizona University, and we couldn't be more happy with the welcome that we've had at the conference so far. And we were at the Sustainability Fair yesterday at Shiprock. Had a wonderful time, so I just want to thank the conference conveners for inviting us. But we've had a really great time so far. And so I'm going to talk today about a project that we've had going on at Northern Arizona University since about 2016 was the initial funding. So we really started up in 2017. And it's all about mapping connections in the economy. And it spread out, or it was initiated from this idea of trying to understand where when water is consumed to produce a product, where is that water going to? When we first originated the idea of building out this big data set for understanding all of the connections in food, energy, water systems, we were located in Phoenix. And so understanding these connections of where our water is being used and consumed and where it ends up going was of great importance to us at the time. And I'd also, and still is, and I'd also like to, before I get started, thank collaborators on this project, Jessica Archibald and Stephanie Deo, who is here today, Anona Miller, Darren Bingham, and Sean Ryan. And I left off one student, and I'm sorry, and I know she's on Zoom, so I apologize. With that, I just want to start off with this saying all of us are inherently connected through the food we eat, the water we drink, and in our daily, and use in our daily lives, the electricity that powers our homes and businesses, the products we buy, and the ecosystems and environments that sustain our lives and communities. This was the first instance of the White House Water Summit report from March of 2016, which seems like a lifetime ago. And for me, coming up from Arizona, from Flagstaff, and I drove up from Phoenix, this idea of connection is very, very real driving into this area. So driving from Shiprock to over here into Farmington, you see Four Corners Power Plant and the San Juan Generating Station, the smokestacks off in the distance. And that's electricity being consumed in Phoenix, being consumed in Flagstaff, being generated with water being consumed here. And so understanding that connection, that's really what we're trying to do for very, very a small effort of trying to do that for everywhere on everything. And so this leads us to this initial project that we started 5 years ago now. It's called the Fusion Project. So it's an acronym for Food, Energy, Water System Data Fusion. And through this effort, we've developed a data set. We're now into our second version of the data set, updating it for current years and trying to do some real-time forecasting of connections within the US food, energy, water system. And so we have this data available. It's publicly available. You can go look at our visualization system and we can demonstrate it over at the poster session. But what we try to do is we try to capture these movements at what we call the mesoscale. So this for us is a scale that captures major patterns, a scale where data are widely available without redaction. And what this comes down to in the United States is that it's at the county scale. And so how do we produce this data? Well, what we do is we scrape numerous data sets from federal agencies and we combine them through a series of algorithms to downscale commodity flow data available from the US Census and Oak Ridge National Labs to the county scale and the current versions to urban areas and sub-county scales. And so just as an overview, here are some of the data sets that we pull from. This is a little bit outdated as far as the list, but we have added here to add some additional features. So like I said, when we were pulling this data together and generating it, we quickly realized we generated a data set that was too large for us to view every single thing in it that we would want to see. And we have personal interest in our data, so we're only typically focusing on specific parts of the analysis. So we set out to make a data portal and visualization system available to the public. You can view this anytime, anywhere. I think it's mobile friendly now. The link is fusion.us/viewview. And so on this visualization system, which the screenshot is shown here, any user can generate a custom map and statistical summary of flows for your community's food, energy, water system. And again, this is at the county scale. It's done on the fly, or you can save as a PDF. And the visualization system on the back end is interacting with about 30 gigabytes of data. So this was done in collaboration with a group at Arizona State University called the Decision Theater. So they've done a really great job with this visualization system. So one of the purposes of Fusion, because we had our academic goals initially to develop this data set, was to see how we can support decision-making. And the three basic questions that we try to answer with our data set is, if we're looking from the perspective of your community, where did a good come from? Again, if you're looking from your community, where are goods being produced in my county? Where are they going to? And how did it get between A and B? So you can understand the linkages and the infrastructure dependence your community has to other communities. And so as far as our data coverage, currently we cover every county in the United States. We have the data aggregated at the county level, the state level. We have data now in there for 195 countries, summarized also into 8 foreign regions, and then we also have data for 134 metropolitan areas. Domestically within the United States, if you're looking through our visualization system, you can explore our data for 43 commodity categories, and underneath it, at the global level, we also have data on 1,000 commodities. And along with that, we catalog the transportation modes taken for the trade. So that includes 7 transportation modes, along with the electricity grid, and we also include 9 trade flow analytics. So what started off what we thought was a simple idea of trying to track where water was going after it was consumed in Phoenix has really just blown up into a very large data set. And so obviously the first thing that you think about when you hear the description of this data set and the entire scale of what we're trying to do is thinking about, okay, you're producing all of this data that's supposed to be at the county level. How do we know the veracity of it? How can we verify it? And so shortly after the initial funding of the Fusion project, we got a supplemental award to build on a citizen science component of this. So with this, we can directly engage with communities to, with the data that's in FuView and that we've produced through the Fusion project, to understand where key shortcomings are within our data set, where it works really well, and then also how we can directly engage with communities with utilizing this data for decision making. And so this citizen science effort that we started, it's called Fusion for Community Resilience. It's a data-driven participatory process where we focus on learning, research, and action. We've piloted this project within Flagstaff, and we've expanded the project scope and have piloted it with stakeholders in Guam and in Alaska. And so what we're trying to do with this community science component of the Fusion project is to build community resilience and empowering through understanding a community's food, energy, water system. And with this, what we're trying to build when we're increasing knowledge about food, energy, water supply chain, food, energy, water system supply chains. We want to increase knowledge about at the personal scale, the community scale, and at the regional, national, and global scale. One way that we've been utilizing and have had success with the Fusion for Community Resilience program is directly engaging and linking our data and our system with efforts by FEMA and their supply chain resilience efforts. And where we've been focusing our efforts are on the phase 1, phase 2, and phase 3 portions of this critical lifeline supply chain guide. So now I'll get into a kind of shift the focus of this talk. Within the abstract, talked about food systems for the Four Corners area. And so I'll show some results and some maps from FuView, and then some additional results. But as far as how I'll be showing some of these data, what we're trying to do with mapping, this initial mapping effort is separating the food supply chain into steps 1 and step 2. From step 1 from farm to manufacturing distribution, and step 2 from manufacturing and distribution to consumption. So the scope of the area that we're looking at, so here's a map of the Four Corners, and the commodities that I'll be showing maps for are agricultural products, meat and seafood, mill grain products, prepared foodstuffs, and mixed freight, which includes prepared foodstuffs. So first thing that we should note about food supply chains in the West is that unlike, or I guess the best way to phrase this is, it's very similar to water systems. There's a stark divide in the U.S. food system around the 100th meridian. To the west of the 100th meridian, supply chains are long, and that creates some critical vulnerabilities when supply chains break down. East of the 100th meridian, supply chains are dense, and there's a lot of areas for redundancy. And so map here on the left is showing for the domestic trade networks for 4 commodity classes in the U.S. and unfortunately the caption got taken off of this image, but A, the green trade network map is for crops. B, the blue network is for animal feed. C is for live animals, and D is for meat and seafood. And so you can see there's quite a bit of density in the trade networks for crops, for meat and seafood, and for animal feed. And the map to the right here shows a zoomed in version of that if you're just to extract some of the key trade linkages for the San Juan County. And what this shows is that major linkages for San Juan County are the Phoenix metropolitan area, the Denver metropolitan area, Bernalillo County and Albuquerque, and then El Paso and Dona Ana County in southern New Mexico. So now I'll get to some of the maps. So this is what our visualization system looks like. So with this visualization system, you can look at individual counties, individual states, countries, or any group of counties or states that you want to look at. And so the groups of counties that we're looking at here are the counties that have not blue dots, but black dots on them. So a range of counties from southwestern Colorado, southeastern Utah, northeastern Arizona, and northwestern New Mexico. And so agricultural products, these are a range of goods. Mainly, these are table crops. And so you can see for the Four Corners regions, the major linkages for these products are Mexico, #1, Doña Ana County, sorry about the pronunciation. #2, which also is an influence of trade flow across the border, Maricopa County and Cochise County in Arizona. Meat and seafood, the major locations of the sourcing pattern for that looks similar to agricultural products, but here, notably, there isn't the influence from the cross-border trade flow, where there are key linkages to Maricopa County, Albuquerque, and the Dallas-Fort Worth area. And the areas shaded in gray in Iowa, Arkansas, and Mississippi would be external sources of pork and chicken. Milk grain products, very similar pattern, where there's key linkages to Phoenix, Albuquerque, and areas in Texas. So this one would show the Lubbock area in McAllen, Texas. Foodstuffs is very interesting. I think this is the only one that shows key local dependencies, and this is showing local distribution capacity, but also dependencies into Arizona and New Mexico. So what does this all mean? I'm showing a bunch of maps, and you could spend hours or minutes on our visualization system. But with this data that we've collected and we've created, we want to answer questions about how resilient are food supply chains for a community? How vulnerable are they to specific events? And so this is a map from a paper that we published last year that looked at measuring food supply chain resilience across the United States and the ability to withstand shocks. So with this paper, we took I call it a very civil engineering approach to evaluating food supply chains. We developed IDF curves for understanding how areas would react to specific food supply chain shocks of varying sizes. And so this is one of the results here. And what I think is interesting, especially for the San Juan County area, is that despite the lengthy supply chains that is shown on a previous slide, it's actually one of the has more resistance to a shock than other areas across the West. And so what this map is showing is what the 100-year flood equivalent to a food supply chain shock would be. And so for what this is saying here for San Juan County, the 100-year food supply chain shock is a decrease in about decrease in availability of about 24% of food supplies, whereas in southeastern Utah, it's closer to a 36% decrease in available food supplies. So I think that's an interesting result, and what that shows is specifically with San Juan County, New Mexico's food sourcing pattern. It's there aren't any big fish in the food supply chain network, and the areas that it's dependent upon also have diverse and resilient supply chains. Another aspect of this, and so what I was showing were results from data from the Fusion project. What we're trying to do with this next iteration of the project is we can provide data at the county level, but especially if you're out west, county, it doesn't provide a lot of detail. You know, if we're coming from Coconino County would be, I think the 7th would be larger than 6 states. I think if you were to put Coconino County in a size of states by square miles, it'd be West Virginia, Coconino County, and then 7 other states. So counties sometimes mask some of the dynamics of what's going on in the ground. And so this next iteration of the project, what we're trying to do is tie flows that we see and can observe at the county level to actual facilities on the ground. And so this is a result of the work that the students and a VISTA volunteer have from their work from this past semester of doing a detailed facility levels food supply chain mapping of the New Mexico and the Four Corners regions, from Farmington to Albuquerque, Santa Fe, and the Tri-Chapters region. And the graphs here on the right show basic statistics graph from a few view of food inflows and outflows. And from the overall statistics, you can see that these areas, there's a large inflow of food, but not a large outflow of food. And so another aspect of this project, and tying this to what we see on the ground to what's going on within the global economy, what I wanted to change the slide title to was Global Demands, Local Impacts. And so this is from a study that we published in 2020, looking at surface water withdrawals for cattle feed crops across the Western United States, and how that is tied to impairment of native fish species. And through this process, we've mapped out the areas in the country and globally that through consumption of beef products and agricultural feed are driving local impacts to Huck 8 watersheds at the Huck 8 watershed level. And you know, unfortunately, this map is showing as at the U.S. scale. You can see in the at least in the Four Corners region, the impact to native fish species has been at the very low end of the spectrum compared to areas in California, Nevada, Utah, and Arizona. So with that, I'd like to circle back to one of the first slides in this talk and just remind us of how we're all inherently connected. And this map here on the right is showing it's a map of from a recent paper we just published this year on the Colorado River Basin, and where we built a network analysis of linking hydrologic flows within the rivers to legal abstractions from rivers to the economic trade within the basin in terms of virtual water. So there instead of taking this normal look of these are the water allocations from the Colorado River Basin per the Colorado River Compact, what does that look like after we adjust for how water consumed, Colorado River water consumed within the basin is redistributed through electricity, through crops, and through other goods. And so with this connection and tying back to the map showing the connections within the food system to Maricopa County, that's one thing I want to drive home. So, while central and southern Arizona is consuming electricity that's generated here using local water, the water that's flowing through the San Juan River into the Colorado River, and then some of it making it into the Central Arizona Project, that's being used to produce goods, agricultural products and dairy and other products in Phoenix that are then shipped back up into the Four Corners regions. So this idea of a cut to the Colorado River that would affect farmers in Central Arizona has a very real impact, has the potential for a very real impact across the basin through these connections. So with that, I'd just like to open it up for questions. I don't know the time that we have left. But any of the papers here that have shown figures from, happy to share. And we'll have a poster where we can talk about the work a little bit more.
Any questions? Doesn't appear that there's any on Zoom, but if anyone would like to ask any questions, we're good on time too. We have a few minutes till our next presentation.
I have a question. How would a city planner act on this data? What would that look like in action, then utilizing this system to then implement a strategy? Would that be into regionalizing food systems? What would that look like in action using this data to make real changes on the ground in how supply chains work?
Right. So one way is just to build those collaborations and networks to understand impacts. If we're in the Phoenix metropolitan area, that we're very much connected to impacts that happen in the Four Corners, impacts in Albuquerque through these networks. How that works for a city planner specifically, these could be linked into climate action plans, regional resiliency plans, or vulnerability assessment. So what are the key vulnerabilities in my city's food system? What are they locally? What for distribution or cold storage or something like that? What are they regionally through impacts of water compacts or hydrologic stress to surface water? Another way that we've been able to engage with folks at the city level is through emergency management offices. We've had a collaboration with FEMA to show snapshots of what this information for specific areas and what the potential impacts of for example, the Cascadia subduction zone event. How would that affect flows into and out of Seattle? Or Wasatch Front, how would that affect the distribution of petroleum supplies through the Intermountain West? So we've done regional vignettes to show the interconnectedness of supply chains on specifically critical lifeline supply chains, so food, energy, water, medical supplies. And showing that and discussing that with emergency management cohorts so that they can start incorporating that into their plans and their thinking.
Thereby increasing maybe supply or diversification.
Supply diversification, yeah. And there's a double-edged sword with diversification. You can over diversify, there's a sweet spot, there's a Goldilocks zone. You don't want to have too many suppliers because then you can't keep track of everything. But you don't want to have too few. You don't want to be dominated by a big fish in the pond, so to speak.
The data is beautiful.
Thanks. And I would also say thank you to Jessica and Steph who are here. They did a lot of data collection. They probably know more about the area. And they remarked yesterday, oh, it's so nice to be here. We've been looking at this area on Google Maps for the last 3 months, so it's nice to actually see it in person. That's a good question. I think that's an area that we're getting to. We've been developing a routing algorithm to help with that, so we could actually start to evaluate that. So that is in our development plan. And part of that also is tricky because some of that is operational at the facility level that we haven't really got to. With our data right now, where it's just generalized at the county level, it's really hard to, the redundancy aspect of that is probably best answered at the facility level. So we'll be getting there. And that's, it's, when you're setting out initially, you think these are the timelines we're going to get to and hit. And then, things happen. And so we definitely have to shift the timeline to the right a little bit on some aspects of the project.
Good question. Curious about or aggregated data at state level, maybe county level. There's just so much information. But also be interested in what states are relying on other states. So I guess it's
Yeah. So we do have right now in the visualization system, we have county, state, and country. And I'm actually going to have country be named international, because I'm always like, oh, I'm going to go to country, actually go to county, and vice versa. So you can look at state, and you can look at some of all of these flows at the state level, which I think provides probably a better summary view on a lot of these for a lot of these metrics and a lot of the data, because it's easier to think about a county or a state as a whole rather than just Bernalillo County or just Maricopa County.
I just wanted to say that I really, really love that this project is it's impressive, and talking about the educating the citizens and using the solutions for also this project, I think is very important, because I guess not all of us in our daily life we think about where our food is coming from, or what would be, let's say, if climate change increases in this area, what type of foods will be missing from our supply chain, and how that might affect us in the future. And also, coming from Puerto Rico, I think places are very that have a lot of risk of getting hurricanes or any other hazards. I think this is very important for risk management and planning for those locations, so that we can be better prepared food-wise.
Yeah.
So,
yeah, that's actually one of the, I'm glad you brought that up. That was when we were doing exit interviews of our first cohorts. That was some of the things that we heard most often is you made me think about where all of this everyday stuff that I've never thought about in my life comes from. And that's really opened up my eyes about my local water footprint, my food, where my food's coming from, and how my life might change under climate change. And so that was, from the educator perspective rather than the researcher perspective, that was very, enlightening and, really nice to see that we had that impact. And also I wasn't expecting that. So that was also oh, that's really nice. And one thing I wanted to mention, so specifically with the data sets we're pulling from, they don't cover US territories. And that's a really big shortcoming that we have here. Guam gets, and American Samoa and the Northern Mariana Islands, they're in just Eastern Asia foreign zone for the county level data, and Puerto Rico is in a group that's with the Caribbean and South America. So that's a really big shortcoming in the data right now. We can kind of back into it for Puerto Rico, there's trade flow coming out of Jacksonville that's typically just going to Puerto Rico. But we've been working with a professor at University of Illinois, Urbana-Champaign, and one of his graduate students to see how we can build a comparable data set for Puerto Rico.
I think that would be great. And also, I guess from my island perspective, like empowering people, there's many, like, I think so many people like look down in agriculture, but having these and helping people visualize how much we depend on like either the mainland or other places for produce can actually empower youth and more people to be involved in that supply chain so that we can be more like sustainable in cases of disasters.
Yeah.
So it would definitely be great.
Yeah, and I think another feedback I've had in one of these exit interviews is when you see some of the scales of numbers that get produced in agriculture, and then you try to contextualize that it's people doing that work, then it really drives home this idea that there's a lot of hard work in, especially in producing commodities at the lower, towards the primary extraction industries. And so it's really underscores like there's a lot of work to produce agriculture. They're producing a lot of material, and moving that across the United States is another challenge. I guess I'll be done. Thank you very much for listening.
All right. Thank you, Dr. Rushford. All right. And to close out our oral presentations for the day, we're in for a double header presentations from Dr. Kofi Jaman. Just a moment. Kofi Jaman is an assistant professor in the Department of Plant and Environmental Sciences at New Mexico State University. His main research focus is irrigation management at field and regional levels via in situ soil moisture monitoring and appropriate modeling. Kofi joined NMSU in 2017 after about 4 years working at the African Rice Institute in Senegal. Dr. Jaman, thank you so much.
Okay. Thank you for the presentation. My name is Kofi, and I'm an assistant professor at the NMSU. We have a research farm within NAPI, and Dr. Lombard there is our boss at the station. So it's a teamwork, and not just my work, but the whole team. Yeah. All the presentations before me, everybody was talking about how do we improve, how do we increase water use efficiency at the farm level. So I won't go into the introductions anymore. My introduction has passed, so I will just show here how do we increase the crop water use efficiency. So this research is focusing on when is the best time to plant corn, and which density is the best that improve or optimize the crop water use efficiency. So for this research, the work is done at NMSU research station within NAPI's area. For people who know NAPI, we are very close to the NAPI flour mill, and not too far from Region 2 scale. So for this research, I've chosen different planting dates. I have 7 planting dates starting from April, and I finish around June 5. And also I have 6 different planting densities starting from 54,000 to 120,000 plant per hectare. I'm not good with English units, so I will go by metric. So we have been planting weekly. We plant a week, but all the 6 densities, starting, like I said, by April 20, and we finish by June 5. We choose those dates because from our experience, for some years, the weather can be very nice in April, which is good for planting. In other years, we can have snow until May. For Navajo agricultural product industry, which is a very large farm, about 70,000 acres, they cannot afford to wait for the best time to plant. If they start during the best moment, they will be late. They will be really late and they could not even finish their planting. So that's what we have done. And the crops were managed equally in terms of fertilizer and irrigation management. So we monitor the plant height, the leaf area index, and at harvest, we count the number of effective plants with years. We have the seed yield, and we have the grain per year, and we use the efficiency estimation equation using the ratio of the yield over the seasonal crop evapotranspiration. So how do we manage water use? The crop irrigation. So we base all the irrigation on the actual crop evapotranspiration. So we use the reference evapotranspiration and the crop KC. So we have a weather station at the farm, which is very accurate and it's automated. You have the data online. You can download data for free. So on a daily basis, we estimate our reference evapotranspiration, and there is a crop coefficient equation developed by the New Mexico scientists for some time ago. So we don't use the FAO KC because usually the FAO KC is very large. It doesn't show the real ET for this location. So for the results, this result was published in this journal. So the main I will show here, the 2020 was warmer than 2019. In 2019, we had snow around May 20th. So the first planting were covered by snow. The leaves of those young plants were dead, but since the growing point was underground, they recovered. And the second year, 2020, instead of snow, we had the sunstorm, which is very hot, and it burned also the leaves, but still those crops recovered because the growing point was underground. In terms of plant height, we don't see any difference between the plant densities, but when the planting is delayed, the crops are getting taller and they have also higher leaf area index. In terms of maturity, when the plant density increases, the higher the density is, the earlier the crop mature. Like shown here, we have different planting dates. Those pictures were taken in September 2020, and we can see the early tree planting dates. The top figures are showing the crops were relatively at the maturity when the June 10, June 5, May 27 planting were still green. In 2017, there was snow on our farm on September 20. So if we have snow, that means the late plantings could not mature. That's what's happening here. We had snow, so the above part of the plant were dead, were frozen, and we were lucky. The down part was still green, and the yield was not really impacted. So the year length and the number of grain per year also decreases when we increase the plant population. In terms of the current number, the grain per year, it decreased also, but there was no clear relationship between those numbers and the planting date. In terms of yield, the yield increased with population and about 88,000 plants per hectare in 2019 has the highest yield. In 2020, the 101,000 plant has the highest yield, but that yield was statistically equal to 88,000 plants. In terms of efficiency, when we combine all 2 years together, the population 88,000 had the best efficiency, the highest efficiency. And also that means that population is the best to be recommended to growers. In terms of a planting window, any planting after May 25 did not really mature. So it's not recommended to plant corn after May 25. I approached some of the growers and they told me the best time to plant corn here in San Juan County is around Mother's Day. So everybody has to keep in mind that around Mother's Day, when you have a small farm, yeah, you can wait until Mother's Day and plant your corn. But if the farm is very large, once the temperature is above 50 degrees, you can start planting your corn when the farm is large. We have tried the same approach with the blue corn, and Brandon here, he works a lot on the blue corn. So we have tried those populations with the blue corn and the organic. So once the population increased above 64,000, the blue corn was giving a lot of tillers without any ear. So you have just the biomass. So for the blue corn and the organic, it's better to use 54,000 plants per hectare, and the yield will still be very good. And the years were really dark blue. So if you have any question, maybe I can respond. I have another presentation. If I knew those two should be together, I should have prepared just one presentation. Yeah.
So you had a decrease in evapotranspiration in your corn because you planted them more closely together? Is that
No.
that logic followed?
No. If you use the theory of the big leaf, if you have the small or the lower population and a higher population, technically evapotranspiration, it doesn't differ that much. Because when the population is high, you have more leaves, you have more transpiration, and very low evaporation from the soil. Now, when you have a very low population, you have a sunlight reaching the soil, you have a lot of space, so evaporation is high, transpiration may be medium, yeah.
So it's less water intensive to plant it closer together because you have less soil evaporation.
Not really. The sum of evaporation and transpiration is mostly the same according to all those plant populations. Yeah. But when you plant during around Mother's Day, the total evapotranspiration is lower compared to the others, but the yield is higher. That's why the efficiency is higher during Mother's Day's planting. Yeah. Yes. Yeah, 54,000. The blue corn was underorganic, so we don't apply any chemical fertilizer. Yeah, we don't apply. We apply some turkey manure and chicken poop. Those, yeah. But at the same time, the field corn doesn't give some tillers. One blue corn plant can give up to 8-10 different tillers. So that is the difference between the blue corn and the field yellow corn. Yeah. No, the yield and the organic is barely 5 tons. And the yield and the conventional, I mean, using all the chemicals, all the fertilizer, we have about 15-17 tons per hectare, which is common in Midwest. Yeah.
Question to your comment. Will be that for your research, do you see you looking at different efficiency for this kind of research in the future?
Yeah. For this experiment, we use the same nutrient management. And now at the end of the first growing season, at the planting, we took the soil samples. We did our chemical analysis. And at the end of the growing season, we took again soil samples within every different plant densities and planting dates. So as I'm still processing the data, I have the data. Yeah.
I'm about to ask that, can we access data?
Yeah, for the soil data, yes. Since we are working for the university, but you have to tell us what exactly you want to do with it. So, yeah. Okay, I guess I can continue with the second presentation. The second presentation is about how do we improve water management in potatoes. Potatoes are very sensitive crops. They are very sensitive to water stress, but they are not aquatic plants. People think the soil should be always at field capacity or above the field capacity to have better potato. But once you are dumping too much water in your field, potatoes are also sensitive to the soil-borne disease. So we have to manage properly our irrigation water and those diseases. But here I'm not a plant pathologist. I send the data to the plant pathologist, but I won't talk about that. So I did this work in farmers' fields. There's a consultant with a NAPI called Navajo Mesa Farm. They just changed their name to Walter Farm. So they basically grow potatoes for chips. So they grow potatoes for Frito-Lay and other companies. So everybody think here, like I always say, I'm coming from very humid area. So I see water as a gold here in New Mexico, basically in San Juan County here. You can't play with irrigation water here. My place, yes, you can do that. But because here, if you don't pre-irrigate, you can't plant your crop. So you have to pre-irrigate. You do rainfeds, you can't get any yield. Maybe in Clovis area, they can get something, but not here. So I designed this experiment using the soil moisture probes to see how much effectively potatoes are using in terms of irrigation water. And also, what is the root zone of potatoes? Sometimes you go to the potatoes fields with the penetrometer. You plant it in the field, it can go up to 3 feet, 4 feet. But you don't see the potato roots after 3 feet. Why should we put so much water in the soil when the crops are not taking it? So I install soil moisture probes within their fields. I choose 5 fields in the first year, 4 fields in the second year. Let's see. So for the first figure there, I chose to manage water, taking into account I irrigate anytime the depletion is about 35% of the total available water within the root zone. So the second picture on the top, you can see when people were irrigating, when the growers were irrigating. So we were supposed to manage our irrigation water within the green space. Once the soil moisture drops within the pink area, that means the crops technically should be under stress. When it's on the blue area, that means the soil is above the field capacity. So you don't need to irrigate. Those 2 points there with above the field capacity, those happens during rainfall event. That means the center pivot was running and there was a rainfall. We cannot stop the center pivot. Here it doesn't rain that much long, so we keep the center pivot running. And the other points within the pink area, sometimes we check the soil moisture, but by the time the pivots move to the sensor, the soil will be under stress at that time. That's why we have those drops. So how do we estimate the crop evapotranspiration? I use 3 methods. I have the water balance method. So I have the data of the soil water across the whole growing season. And I use this probe called Centec. The probe has 5 different sensors within the tube, within the first tube. So we rate the soil moisture at 5 centimeter, 15, 25, 35, and 55. So we install the probe just after planting, and we keep the probes up to harvest. The probes are connected to a telemetry, and we can access our data using our cell phone or using our computer. And this sensor is about 3,001. It is only 2 feet long, but at the same time, some of those are 4 feet and they are about 5,000. And also for this, we need to operate, we need a service, we need subscription. You cannot just run it for fun. So the manufacturer won't give it to you for free. So every year you have to pay 800 for each sensor and you have the whole package. So like I was saying, I use the soil moisture data to estimate the crop evapotranspiration. I also use the FAO permanent equation using the reference evapotranspiration and the FAO KC. Since we don't have any local KC for San Juan County. So for the third method, last year in November, there's a new website called OpenET. That website is designed to show people a monthly ET for different crops. So if you go on this website, you see the US is divided into 2. This is good for the west parts, and we are lucky to be at the west. And when you go, everybody can go on it you can locate your own field. When you locate your own field, you click on it, it will give you the monthly evapotranspiration from 2016 up to 2021. 2020 data is not really good now because they associate the plant, the crop and the ET, but sometimes they use a satellite. So there's a confusion between some crops. So they go underground to check with a few farmers to confirm. So that has not been done for 2021. So please don't use 2021 data. So I download the data from that website. They have 6 different satellites, and they show the ET of each satellite and the average ET using all those. So this data is also published. 2018, 19, they were almost the same, but you can see the wind speed here in San Juan County, everybody knows. In spring is very high, and that is shown there. For the soil moisture, the dynamic of soil moisture. So within the first foot, we have more dynamic in terms of soil moisture. But once you go beyond 40 centimeters, which is more than one foot, the soil moisture doesn't change that much. So when we did the statistics, the real soil depth or the real root zone for potatoes is about 40, the upper 40 centimeters. So for irrigation management, we should consider only the upper 40 centimeters. However, at planting, we should fill the soil profile up to 2 feet. Because if you don't do that, during the active growing season of potatoes, the water will move from the root zone to fill the soil layer below 40 centimeters. So it's necessary to fill that zone. When we compare I don't know if this is the right one. Oh, the irrigation amount, they are almost the same. The irrigation amount in March is basically the pre-irrigation. Potatoes are not planted in March. So that is just a pre-irrigation. And even in April, potatoes are planted usually after April 15. So there's the soil preparation and fumigation, all that process, you need to pre-irrigate the soil. That's why you have that. In September, the potato plants are mostly killed at the end of August. But even if they are killed, we need to irrigate very lightly to build the skin of the potatoes. So if you don't keep the irrigation running, the potatoes, the skin will not be hard. And after harvesting, they can go bad in very short period. Navajo Mesa keep the potatoes until June. We still have some of the potatoes at Napi. If you are lucky, you can see that on Friday for people who are going there. Okay, the evapotranspiration, the soil moisture probes and the satellite data are basically the same, but the FAO KC method overestimates the potatoes evapotranspiration. I mean, the KC of a FAO is just a general KC. Is not. It doesn't take in account our local realities over here. So this is for when you combine both years together, the FAO method overestimates ET by 33%, and the satellite data underestimates ET by 5% only. That can be 5% is nothing. For the soil moisture data, we go to the field. We want to put the sensors where we have a real good plant population. But when you take into account the satellite data, it combines all different places of the fields. And also you have a lot of prairie dogs there. They eat a lot of crops. So the population is not uniform. And also you have advection at the out of the fields, you have the hot air coming within the field. So that increase the water uptake. And also at the same time, when you use the center pivots at the Nappies area, sometimes we have a very heavy wind. So irrigation is not reaching the soil. It goes in the air. All those increase the evapotranspiration. So this is what we have done. And for people who are growing potatoes, they can use the ET data from the satellite or using the soil moisture probes, the best way to manage irrigation water here in San Juan County. Thank you. Any question for me or Dr. Lamba or Brandon? Like I said, we are a team, so if I cannot respond, I'll send to them. Okay, thank you.
Thank you so much. And thank you as well to all of our presenters today. It's been a pleasure hearing all of your presentations. And thank you as well to all of you who've attended so far. It's really great to see people attending both in person as well as our presenter or our attendees who are participating via Zoom. So we've ended a little bit early, but right now we'll be moving into our poster session and reception. There should be some food that'll be reception food that will be going out soon in the lobby area in about probably 10 minutes or so, some hors d'oeuvres and things like that to enjoy. But I encourage everyone to eventually make their way over to our 5 poster presenters. And I want to thank them as well for taking the time to share their poster presentations. I do want to make a correction. In the program, there's a mistake with abstract number 9, where the wrong text was included for that particular abstract. So I believe we've printed off some the correct abstract, and we can hand that out to you as well, so you have the correct abstract for that particular poster. But yes, I guess we can transition over to that now. And thank you so much, everyone.
Thanks, Mark.
Thank you.